Hello students. Today we are going to solve few questions on pipes and cisterns. If you want to practice all the questions from this paper, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Let's begin with question number 1. Two pipes P and Q can fill a tank in 5 integer 5 by 12 and 9 integer 2 by 7 minutes respectively. A waste pipe R can empty it in 10 integer 5 by 6 minutes. If all the three pipes are opened simultaneously, the time taken to fill the tank is. Students, let us understand the question first, right? Here, we'll consider a tank, two pipes P and Q, right? Here, pipe P alone can fill the tank in 5 integer 5 by 12 minutes, whereas pipe Q alone can fill the tank in 9 integer 2 by 7 minutes. And we'll consider one more pipe R which can empty the tank in 10 integer 5 by 6 minutes. Empty the tank, right? So here the question is, if all the three pipes are opened simultaneously, so the time taken to fill the tank. Here, if all the three pipes are open, in such a case, right, two pipes will be filling the tank, filling water in the tank, whereas another type starts to empty the tank, right? So here the total time taken to fill the tank, right? So for that, we'll consider work done by each pipe per minute, right? So if you consider filling the tank is W amount of work, here work is equal to filling the tank or emptying the tank, right? So here, if you take W amount of work needs to be done to fill the tank, for example, same amount of work needs to be done to empty the tank, right? Therefore, if tank contains 1000 liters of water, for example, so to fill the tank, same amount of work needs to be done, and also to empty the tank, same amount of work needs to be done. Therefore, so work here work can be amount of work to fill the tank or to empty the tank, right? Both are same, right? So to do this work, right, pipe P takes this much of time, 5 integer 5 by 12 minutes of time, right? That means in these many minutes, so it does some work, right? That is filling the tank. Therefore, so work done by pipe P in 1 minute. In 1 minute. So here students, this question is based on the concept of work. We all know that work is equal to efficiency into time. Efficiency into time. Here efficiency is nothing but work done per unit time, right? So that means what amount of work has been done in 1 minute. Here unit time is 1 minute, right? So work efficiency is nothing but 1 minute work into time, total time, right? So here, when you consider pipe P, total time is 5 integer 5 by 12 minute, right? So total time to do that work, total time to do that work into 1 minute work is the total work, right? Here work done by pipe P in 1 minute is total work is W divided by 5 integer 5 by 12. Total work by total time, whereas work done by pipe Q in 1 minute, right? Pipe Q's 1 minute work is W by 9 integer 2 by 7, right? So total time taken by pipe Q is 9 integer 2 by 7 minutes, right? Whereas work done by pipe R in 1 minute, here work done is same, though it is the case of empty the tank, right? So what total work is same, work done by total time is 10 integer 5 by 6 minutes, right? So these are the amount of work per minute by each pipe per minute. So here we'll consider the case where all the pipes are opened, right? When all all pipes are opened, right? So work done per unit time by all the three pipes, right? So work done by in 1 minute, by all three pipes, so just we have to add these works. So work done by P plus work done by Q, right? So here minus R, work done by R in 1 minute, you have to subtract that work, because so in such a case, that means where all the three pipes are opened, right? So water is going out of the pipe R, right? Water is going out of the pipe R. Therefore, we have to subtract R, right? So just add first two works, W by 5 integer 5 by 12 plus W by 9 integer 2 by 7 minus W by 10 integer 5 by 6. Right? Here in the third case, in case of pipe R, water is going out of the tank. Right? So simplify it. Here the denominator becomes 12 into 5, 60, 65 by 12. So 65 by 12. So this goes to numerator. It becomes 12W plus. So 9 into 7, 63 plus 2 is 65. So W by 65 by 7. So this by 7 goes to numerator. Minus W by, here also 65 by 6. 6 goes to numerator. So here 19 minus 6 is 13. W by 65. So this is work done per unit time in, by all the three types, all the three pipes, right? So work done in unit time by all the three pipes is 13W by 65. So here numerator, if you take it as total work W, denominator becomes 65 by 13. In other words, you can write it as total work by 13 into 5. Right? So here work done in unit time is efficiency of all the three pipes is equal to, efficiency is equal to total work by total time. Right? According to the formula, total work by total time is efficiency. That means total time taken by all the three pipes is 5 minutes. Right? 5 minutes. Therefore, option A is the right answer, right? So, all the three pipes take 5 minutes of time to fill the tank, right? Where first two pipes are filling the tank, whereas from the third pipe, water is going out, right? Therefore, option A is the right answer. Question number 2. A pipe takes 15 minutes to fill 6 by 23rd part of a tank. Find the time taken by it to fill 12 by 115th part of the tank. So here, so to fill 6 by 23rd part of the tank, right? So to fill this much part of the tank, time taken by the pipe is 15 minutes. This is how we have to solve, right? So 15 minutes by 6 by 23rd part means to fill this much part, to fill the denominator part, right? This much part, time taken by the pipe is 15 minutes. Therefore, that means into, to fill 12 by 115th part of the tank. So what is the time, right? Therefore, so required time is equal to required time taken by pipe to fill 12 by 115th part of the tank is this much, right? Therefore, we'll simplify it. So 15 into 23. This denominator of the denominator will go to numerator. So divided by 6 into 12 by 115, right? Simplify it. So 6 into 2 is 12. Then 23 into 5 is 115. 5 into 3 is 15. So 3 into 2, at last we will get 6. So to fill 12 by 115 part of the tank, pipe takes 6 minutes of time, right? Therefore, option D is the right answer. Question number 3. Two pipes A and B can fill a tank in 3 hours and 7 hours respectively. If they are opened at alternate hours, starting with A first, then the time taken to fill the tank is. So here A and B pipes can fill the tank in 3 hours and 7 hours respectively. In this question also, we are using the concept of work, which is efficiency into time. So in general terms, if you consider pipe A, right, can fill some portion of the tank in first hour, in 1 hour, right? In the next hour, pipe B starts filling the tank, right? In the next hour. Again, pipe A fills the tank, right? In at alternate hours, pipe A and B, right? They fill the tank, right? Next comes pipe B again in next hour, right? And it continues, right? So here we need to find the time taken to fill the tank, time taken by these pipes to fill the tank. That is total time. Total time needs to be calculated, right? So for that, we'll consider in first 1 hour, right? So what is the amount of work or what amount of water has been filled by pipe A, right? So here amount of water filled will consider in the respective hours in first hour, right? So here pipe A can fill the tank in totally 3 hours, right? In total 3 hours it can fill the tank, right? Therefore in 1 hour it can fill 1 by third part of the tank, right? 1 by third part of the tank, right, in 1 hour. Whereas in the next hour, B starts filling the tank. Pipe B starts filling the tank. So 1 by 7, right? Work done here is 1 by 7. Or 1 by 7 part of the tank has been filled by pipe B, right? In first part, if you take 1 by third, next in 1 by 7th part, right? And in the next hour, again it is 1 by third, right? So before going to the third hour, so we'll consider in first 2 hours. So what is the total work done, or what is the amount of tank filled by A and B in first 2 hours? It is, since LCM is 21, so here the numerator is 10, right? 7 plus 3. So 10 by 21 part of the tank has been filled in first 2 hours, right? So I'll show it here, right? Yeah, in first 2 hours, in 2 hours, 10 by 21 part of the tank has been filled, right? It is not the complete tank. So what is the remaining part? Remaining part is 1 minus 10 by 21. So if you consider whole tank as 1 and these parts are 10 by 21, these are parts of the tank, right? So in which water is filled, right? So remaining part is 21 minus 10 is 11 by 21 is the remaining part, right? So in this remaining part, water needs to be filled by again A, B like that, right? So in the remaining part can be written as a 10 by 21 plus 1 by 21, right? 10 by 21 plus 1 by 21. Like this you can consider. This is the whole tank. The remaining parts are 10 by 21 and 1 by 21. Because the remaining part is 11 by 21, right? This can be written as like this, two parts, 10 by 21 and 1 by 21, right? So here again 10 by 21 part of the tank can be filled in 2 hours by pipe A and B, right? In 1 hour, 1 by third part of the tank can be filled as in the previous case, and in the next fourth hour, right, fourth hour, 1 by 7th part of the tank can be filled. So totally it is 4 hours, and again 1 by 21 part is remaining, right? So therefore, so in the fifth hour again A starts filling the tank. Are you getting my point? In the fifth hour, right? Because in the 4 hours, right? 10 by 21, 10 by 21, which is 20 by 21 parts, right? So I'll mention here in 4 hours, 20 by 21 parts of the tank has been filled, right? And the remaining is 1 by 21 part, right? So this should be filled by this part, a small portion of the tank should be filled by A. Whereas in 1 hour, A can fill 1 by 3rd part of the tank, right? Here 1 by 21 part of the tank is remaining, right? So we'll mention here time taken by pipe A to fill 1 by 21 part is very simple calculation, right? So here time taken by pipe A to fill 1 by 3rd is 1 hour because of efficiency of A. So this 1 by 3rd part of a tank, right? So to fill 1 by 3rd part of a tank, time taken by pipe A is 1 hour. Therefore, that means into to fill 1 by 21 part of the tank. So time taken by pipe A is simplified 1 by 1 by 3 into 1 by 21. So very simple calculation. 3 goes to numerator. So it becomes 3 by 21, which is 1 by 7. So here time taken by pipe A to fill the last part of the tank is 1 by 7 hours, right? 1 by 7. What is the total time here? So 2 hours plus 2 hours plus 1 by 7 hour, right? So we'll mention total time to fill the tank is 2 plus 2 hours plus 1 by 7 hours, right? It is 4 integer 1 by 7 hours, right? You can verify it. 4 plus 1 by 7 hours. So 7 into 4, 28 plus 1 is 29 by 7 hours. That is 4 integer. 7 into 4 is 28. 1 is the remainder. So 4 integer 1 by 7 hours is the required time, right? So, right, to fill the tank, total time taken by pipe A and B is 4 integer 1 by 7 hours. Option B is the right answer. Question number 4. Pipes A and B can fill a cistern in 5 and 7 hours respectively. Both the pipes are opened simultaneously, but after 2.5 hours, pipe A is closed. How many hours will pipe B takes to fill the remaining part of the cistern, right? So here, to fill a cistern, right, we'll consider pipe A and B, right? So here, both the pipes, they work for 2.5 hours. They start filling the cistern for 2.5 hours, right? So for first 2.5 hours, both pipes A and B, right, are filling the cistern. After 2.5 hours, only pipe B start to fill the cistern because pipe A will be closed after 2.5 hours, right? So here the question is, so how many hours will pipe B takes to fill the remaining part of the cistern? To fill the remaining part, what is the time taken by B? Right, after 2.5 hours, what's the remaining time taken to fill the cistern, right? So here, if you consider pipe A plus B for 2.5 hours, both the pipes, they start working, right? They start to fill the cistern. After 2.5 hours, only pipe B will fill the cistern completely. What is the time taken by B? That's what the question is, right? For that, we'll consider the given information. Only pipe A alone can fill the whole cistern in 5 hours. It is given. Whereas pipe B alone can fill the cistern in 7 hours. Right? So here in every hour, what is the portion of the cistern can be filled by both the pipes? Right? For that, we are using the concept of work. Work is equal to efficiency into time. Right? So here in this paper, each and every question is based on the same concept, work. right? Efficiency into time. Here work is nothing but, so the filling the tank or filling the cistern is considered as work, which is equal to efficiency. Efficiency means portion of the tank filled per unit time, right? So work in unit time is nothing but 1 hour, right? Here the time is taken in terms of hours, so unit time is 1 hour, right? So work done in 1 hour into total time taken. Efficiency is nothing but what portion of cistern is filled in unit time, right? Into total time is considered as the work done, right, to fill the cistern, right? So here, with respect to pipe A, right? So portion of the cistern filled in 1 hour by pipe A, right? Or you can consider it as work done by pipe A. Work done by pipe A in 1 hour. 1 hour is, if you consider W as the total work done to fill the cistern, right? So work done by pipe A in 1 hour is total work done divided by time taken by pipe A is W by 5, right? Whereas work done by pipe B in 1 hour, B can fill the tank in 1 hour, right? What portion of tank or cistern can be filled? W by 7 portion of the, here W is nothing but total work to be done. So which is work to be done to fill the tank, right? W by 7 part of the cistern can be filled by pipe B in 1 hour. If both the pipes are opened, right? If both A and B are opened for 2.5 hours, right? If pipe A is open for 1 hour, so it can fill W by 5 portion of or 1 by 5 portion of, right? Forget this W. So just consider 1 by 5 portion of the cistern can be filled by pipe A, and 1 by 7 part of the cistern can be filled by pipe B in 1 hour, right? Therefore, in 2.5 hours, if both the pipes are opened, right, then it becomes A plus B. Work done by A and B in 1 hour becomes, so in 1 hour, it is W by 5 plus W by 7 into in 2.5 hours, right? Therefore, what portion of work can be done in 2.5 hours, right? So we'll consider the LCM. 35 is the LCM. So numerator becomes, yes, 12W into 2.5 means 5 by 2, right? So 5 into 7, therefore 12 by 14 into W, right? That means 12 by 14 portion of the cistern will be filled by A and B in 2.5 hours, right? In 2.5 hours. What is the remaining portion of the cistern, right? We'll consider remaining portion of the cistern. Remaining portion of the cistern to be filled or remaining work to be done, right, is equal to, so total portion of the cistern is work done, total work needs to be done, minus 12 by 14th of work already done by A and B in 2.5 hours. So it is 2 by 14th of W or 1 by 7th of W is the remaining portion, right? So in which water to be filled, right? So what is 1 by 7 into W? Work done by pipe B in 1 hour, right? And it is given that after 2.5 hours, B starts filling the remaining portion of the cistern, right? Therefore, remaining portion will be filled by pipe B in how many hours? In 1 hour, because the efficiency of B is, capacity of B is 1 by 7th of total work, right? Which is already given. Therefore, remaining portion of the cistern will be filled by which pipe? filled by pipe B. Pipe B in according to the given information, 1/7th work is capacity of pipe B, right? In 1 hour. Therefore, filled by pipe B in 1 hour. Therefore, the question is, so how many hours will pipe B takes to fill the remaining part of the cistern? B takes 1 hour time, right? 1 hour time to fill the remaining part, right? Option C is the right answer. Question number 5. Two pipes can fill a tank in 10 minutes and 30 minutes respectively, and a third pipe can empty the tank, full tank, in 20 minutes. If all the three pipes are opened simultaneously, the tank will be filled in. So students will consider two pipes, A and B, can fill a tank in two different time durations, right? 10 minutes and 30 minutes respectively. Whereas third pipe can empty the tank, right, in 20 minutes. Third pipe can empty the tank in 20 minutes. So here, if you consider first pipe, A pipe, B pipe, right? So let it be C pipe, the third pipe B, right? So here, so pipe A can fill the tank means, so in 10 minutes, right? So pipe A can fill whole tank, right? So full part of the tank will be filled in 10 minutes, right? So here pipe A can fill whole part. Whole part means one. One will be taken as whole, right? Therefore, in 1 minute, what part of the tank will be filled, right? So, therefore, in 1 minute, right? In 1 minute, pipe A can fill 1/10th part, right? 1/10th part. In 10 minutes, if it can fill the whole part, that means in one part. So in 1 minute, it can fill 1/10th part, right? Here 1/10 is nothing but, so it is taken from the concept of work is equal to efficiency into time. Here efficiency is nothing but work done in unit time. In 1 minute, pipe A can fill whole work, which is one part, by 10. 10 is the total time, which is 10 minutes. Right? Here 1 is considered as the whole work by 10. So denominator 10 indicates the total time, which is 10 minutes. Right? Therefore, in 1 minute, pipe B, what about pipe B? Pipe B can fill what part of the tank? Since B takes 30 minutes to fill the whole tank, therefore in 1 minute, pipe B can fill 1/30th part of the tank, right? Whereas third pipe, right, in 1 minute, pipe C it cannot fill the tank, it can empty the tank. It can empty 1/20th part of the tank, right? Here work done to fill or empty the tank is same here, right? So either you have to fill the whole tank, or you have to empty the whole tank. Here work is same. Therefore, in 1 minute, pipe C can empty 1/20th part of the tank, right? So here the question is, if all the three pipes are opened simultaneously, so we'll consider their 1 minute work first, right? So if all three pipes are opened, right? So then what's the question? So the tank will be filled in, time taken to fill the tank, right? Time taken to fill the tank will be, we'll consider the sum of first two types, because first two types can fill the tank. So their work in 1 minute, right? So pipe A can fill 1/10th part. So 1/10 plus pipe B can fill 1/30th part, whereas pipe C can empty the tank, therefore subtract 1/20th part, right? Since 60 is the LCM, numerator becomes 10 into 6, 30 into 2 plus 2 minus 20 into 3. Therefore, it is 8 minus 3 is 5/60. If work is considered as 1/60/5. 5/60 can be written as 1/60/5. So, which is 1/12. Right? Here 12 indicates the time taken, total time. 1 indicates the whole work by time, right? 1 indicates to fill the complete tank. Time taken will be 12 minutes. 12 minutes, work by time, right? That's what the question is, right? If all the three pipes are opened simultaneously, so work done by them per unit time, right? So work done per unit time is nothing but their 1 minute work, right? 1 minute work of pipe A, 1 minute work of pipe B, and that of C, right, is equal to 1/12. That is work by time. Here time taken to fill the tank if all the three pipes are opened is 12 minutes. Option A is the right answer. Question number 6. Two pipes A and B can fill a cistern in 37.5 minutes and 45 minutes respectively. Both pipes are opened. The cistern will be filled in just half an hour if pipe B is turned off after. So that means both pipes are opened, right? If both pipes are opened and cistern will be filled in just half an hour if pipe B is turned off after. That means, so in the last half an hour, pipe A fills the cistern, remaining part of the cistern, right? So what is the remaining part or first part of the cistern? That we need to find out first. This first part will be filled by B, right? Second part will be filled by A in half an hour, right? So depending upon the capacities of two pipes, right? Considering the total work to fill the cistern as W, we'll consider total work to fill the cistern as W. We'll consider the capacity of each pipe, right? So the capacity means 1 minute work of each pipe, right? So 1 minute work of each pipe. That means in 1 minute, what amount of work can be done? How much, that means how much portion of the cistern can be filled is called efficiency or 1 minute work of pipe A is. Here pipe A takes 37.5 minutes to fill the cistern completely. Therefore, in 1 minute, pipe A can fill W by 75/2. 37.5 means 75/2 portion of the cistern, right? Whereas 1 minute work of pipe B is W by 45. B takes 45 minutes, right? So here 1 minute work of A is W by 75/2. Here this portion of work done by A in half an hour, right? So half an hour work of A. A is equal to, here 1 minute work is 2W by 75 into half an hour work means 30 minutes, right? Half an hour work means 30 minutes work of A. Therefore, it is, you can simplify or leave as it is, right? So here 5 into 6, 5 into 15, right? So 12W by 15 portion of the cistern can be filled by A in half an hour, right? What is the remaining portion, right? So here, so when you look at the diagram, so in half an hour, right? In half an hour, so not first part of the cistern, it is second part of the cistern. We are coming in reverse manner. So last, how much portion? 12 W by 15 or 12/15th portion of the cistern can be filled in half an hour by pipe A. Whereas pipe B fills remaining portion. What is the remaining portion? Remaining portion of the cistern or remaining work to be done is equal to, so total work to fill the cistern minus already done work is 12 W by 15, right? Therefore, it is 3 W by 15 or 1/5 of portion, right? 1/5 portion should be filled by pipe B in how many minutes, right? So very easy calculation. So time taken by B to fill remaining portion is equal to, since we are using simple concept of work, is equal to efficiency or 1 minute work. Unit time work is called efficiency. 1 minute work into time taken. Here we need time taken. So time taken to fill remaining portion. So work to be done to fill the remaining portion, right? So remaining portion is nothing but 1/5 of the work, right? So 1/5 of work to be done, right? To fill the remaining portion divided by 1 minute work of B, right? Therefore, 1 minute work of B is W by 45. So, W by 45, right? Therefore, time taken by B to fill the remaining portion is equal to, so 1 by 5 W whole divided by W by 45. We can cancel W and W. 45 goes to numerator. So, 45 by 5, which is equal to 9 minutes. So, B takes 9 minutes of time, right? Here we are solving this question in reverse manner, right? So, first B fills the cistern in 9 minutes. Which portion of the cistern? 1/5 portion of the cistern in 9 minutes. After that, in half an hour, A fills the remaining portion, right? Only 1/5 small portion of the cistern will be filled by B in 9 minutes. Whereas in half an hour means in 30 minutes, A fills remaining portion, right? So that here after 9 minutes, pipe B is turned off, right? Therefore, the question is, if a pipe B is turned off after 9 minutes, option C, right? This is after 9 minutes, the cistern will be filled by A, right? Therefore, option C is the right answer. Question number 7. A cistern is normally filled in 8 hours but takes 2 hours longer to fill because of a leak in its bottom. If the cistern is full, the leak will empty it in. So let us understand the question here. We'll consider a cistern, right? A pipe can fill the cistern in 8 hours. In 8 hours, the cistern can be filled, right? But due to a leak in its bottom, it takes 2 hours longer, right? Therefore, in an ideal condition, it takes 8 hours to fill the cistern, but in real condition, it takes 8 plus 2 hours, 2 hours longer, right? So it takes 10 hours to fill the cistern, right? So here the question is, if the cistern is full, the leak will empty it in. So in case the cistern is full, right? Time taken to empty the cistern, right? So because of the hole in it, so it will empty the cistern, right? Therefore, time to empty, time taken by the hole to empty the cistern is the question, right? So for that, first we need to consider in 1 minute what portion of the cistern can be emptied. I'll repeat once again. In 1 minute, portion of cistern, right, can be emptied, right, or to be emptied. If you find this in 1 minute, what portion of the cistern can be emptied? So it is nothing but in scientific term, we call it as efficiency, right? Efficiency of what? Efficiency of the leak or hole. right? Efficiency of the whole. In 1 minute, what portion of the cistern can be emptied? It is nothing but efficiency of the whole, right? So if efficiency is expressed, efficiency is always work by time, work by time. So in order to do some work, what time it takes, right? That's what the efficiency, right? Work by time, work per unit time is called efficiency. So if you find in 1 minute the portion of cistern, what portion can be emptied, it is nothing but the total work. Here work is to empty the cistern. Work is to empty the cistern in how many hours? In how many hours? Here, how many hours gives the answer, right? So the leak will empty it in, right? For that, so we'll consider two conditions, in ideal condition and in real condition. In ideal condition, so we can fill the tank in 8 hours. A pipe can fill the tank in 8 hours, right? In ideal condition, right? Therefore, in 1 hour, in unit time, what portion of the cistern can be can be filled, right? That is what the ideal case, right? Therefore, so portion of cistern to be filled in 1 minute. In 1 minute, not 1 minute, in 1 hour. Sorry, here the unit is in terms of hours. The portion of cistern to be filled in 1 hour is 1/8 portion. 1/8 of cistern, right? So a small portion of the cistern can be filled in 1 hour in ideal condition, because it takes 8 hours to completely fill the cistern. Therefore, in 1 hour, we can fill only 1/8 portion of the cistern. But in real condition, it takes 2 hours longer, right? Therefore, portion of cistern to be filled in 1 hour. Really, it takes 1/10. It takes 2 hours, 2 hours more time, right? That means 10 hours of time to fill the cistern. Therefore, in 1 hour, so we can fill 1/10th portion of the cistern, right? So it is still lesser than the previous one, 1/8, right? Small portion of cistern can be filled in 1 hour. So here, this portion which I am showing, this portion, right? This portion of water will get leaked out of the hole, right? Therefore, leak in 1 hour, right? Leak in 1 hour at the bottom is 1/8 in ideal case minus 1/10, right? So leak in 1 hour is, it is 10 minus 8 is 2 by, not 2 by, here since LCM is 40, 8 into 5, 10 into 4. Yes. Therefore, 1/40th part of the whole cistern, the shaded part is nothing but 1/40th part of the whole cistern, right? This 1/40th part of the cistern will get leaked out, right? This portion of water, this amount of water will be leaked, right? Here the question is, if the cistern is full, the leak will empty it in. So if the whole cistern is full, right, in how many hours the full cistern will be emptied, right? So for that, this leak in 1 hour is nothing but efficiency of the whole, right? Leak in 1 hour is efficiency of the whole. Therefore, so completely, right? So if you want to empty the complete cistern, so how many time it takes? So what is the time? So it is nothing but, the leak in 1 hour is nothing but efficiency, which is equal to work by time. Work is the whole part, that is 1, right? The complete whole cistern whole cistern is considered as 1 divided by 40 hours time taken to leak the water, right? So it takes 40 hours to empty the cistern, right? If the cistern is full, the leak will empty it in 40 hours. Option C is the right answer. Question number 8. Pipes A and B can fill a tank in 10 and 15 hours. So how much time will they take together to fill the tank? As in the previous cases, here also we are using the concept of work is equal to efficiency into time, right? Efficiency into time. Here, work is work done to fill the tank, right? So total work to fill the tank, which is equal to efficiency. In 1 hour, what portion of the tank can be filled, right? So work in 1 hour. Work in 1 hour into total time. Right? So here, if you consider work done by pipes A and B individually in 1 hour, right? First, we need to consider work done by these two pipes in 1 hour. Here the question is, if they start working together to fill the tank, that means add their work in 1 hour, right? So you can express in terms of total work and total time, right? So first work by pipe A in 1 hour. In 1 hour, right? So it can fill 1/10th portion of a tank, because to fill the complete tank, pipe A takes 10 hours of time. Therefore, in 1 hour, a small portion can be filled, right? Which is 1/10th portion of a tank can be filled. Similarly with pipe B, right? So in 15 hours, it can fill the complete tank. Therefore, in 1 hour, it can fill 1/15th part, right? Therefore, work done by pipe A in 1 hour is 1/10th, or you can consider W as the total work. So work in 1 hour, it is nothing but efficiency, and the time is T, right? Both the ways you can consider. Work done by pipe A in 1 hour is the total work divided by, here in 1 hour is unit time, right? So which is nothing but efficiency, right? So efficiency of pipe A is total work divided by total time taken by pipe A is 10, W by 10, right? Whereas work done by pipe B in 1 hour is total work to be done is W, whereas B takes 15 hours. So W by 15 is the work done by pipe B in 1 hour, right? A small portion of the cistern can be filled in 1 hour. If they start working together, right? So if A and B work together, that means if both the pipes start filling the tank, so we'll consider their 1 hour work, right? Therefore, W by 10 plus W by 15, right? So W by 10 plus W by 15, here the LCM is 30, right? 15 into 2 and 10 into 3. And the numerators become 3W plus 2W. So we have 5W by 30. So express the numerator in terms of the total work, which is W, by 30 by 5. 30 by 5 is nothing but 6, right? W by 6. Since this the LHS part is the efficiency, their work in unit time, right? W by 10, or work of A and B in unit time, right? In 1 hour. Their 1 hour work, sum of their 1 hour work can also be taken, right? Efficiency is equal to total work by total time. Total work by total time according to the concept. Therefore, both A and B, pipes A and B take how many hours? 6 hours of time to fill the tank or fill the cistern, right here. So here, to filling the cistern itself is the total work. Therefore, So the question is, how much time will they take together to fill the tank? It is not the cistern here, it is the tank, right? Therefore, pipe A and B take 6 hours of time to fill the tank. Option B is the right answer. Question number 9. Two pipes A and B would fill a cistern in 20 and 34 minutes respectively. Both pipes being opened, find when the first pipe must be turned off so that the cistern may be just filled in 17 minutes. So students will consider a cistern, right? So here pipe A can fill the cistern in 20 minutes. Alone can fill the cistern in 20 minutes. Whereas pipe B alone can fill the cistern in 34 minutes, right? So if both the pipes are opened, so here the first pipe must be closed, right? So the time at which the first pipe must be closed so that the remaining portion of the cistern will be filled in 17 minutes by second pipe B, right? So here, so for example, here pipe B, right, in 17 minutes, it fills the remaining portion of the cistern, right? So for example, some portion of the cistern is filled by pipe A at first, and the remaining portion is filled by B, right, in 17 minutes. So what portion of the cistern is filled by B? First, we need to consider that, right? Then what is the remaining portion, the first filled portion by A, that we need to consider, right? First, we need to consider portion filled by B, portion filled by B, then portion filled by A. That is nothing but the remaining portion, right? Filled by A at first, right? Then time taken by A. Time taken by A to fill the first portion, right? So here A first, according to the question, A fills the cistern at first, right, in so and so minutes, right? Then B fills the cistern. It completes the system, filling the cistern completely in 17 minutes. Here the question is, so when the first pipe must be turned off. So when should be the first pipe A should be closed such that in the remaining 17 minutes, the cistern will be completely filled, right? We'll go accordingly. Here also, students, we are using the concept of work is equal to efficiency into time. Here the work is nothing but filling, right? Filling the cistern. Filling cistern is considered as the work, and efficiency is nothing but, so work done per unit time in 1 minute, right? Work in 1 minute. Work in 1 minute is considered as efficiency of that respective pipe, and time. So total time is considered as the time, right? First, let us consider portion filled by B, right? So here it is given that in 17 minutes, right, B completes filling, right? Whereas in ideal case, B completes filling in 34 minutes, right? Therefore, portion filled by B, portion filled by B. We are using the concept of work, right? Here, work is efficiency in into time. So, portion filled by B is nothing but portion filled in 1 minute, right? Portion filled in 1 minute into portion filled in 17 minutes. This is the total portion filled by B, this portion, right? In 1 minute, what portion of the cistern will be filled by B? So in 1 minute, in the sense, the efficiency is work by time, right? We know that efficiency is work by time. If you consider W as the total work divided by, so in ideal case, B takes 34 minutes of time to fill the tank. So this is the portion of the cistern filled in 1 minute. Per unit time is 1 minute. Into in 17 minutes. What portion of the cistern will be filled? It is W by work done by 2. Or half a portion of the cistern will be filled in the last last 17 minutes. Half of the cistern will be filled in last 17 minutes. And the remaining portion is half, right? Half is remaining. Therefore, portion filled by A is the remaining portion. That portion is filled at first, right? Remaining portion. So we are considering this solution in the reverse order, right? So remaining portion is, yes, of course, 1 minus 1 by 2, which is half of the portion is remaining. That will be filled by A in how many minutes, right? So time taken. Time taken by A. Time taken by A is equal to, here the total work by efficiency. Efficiency of A is the time taken by A. Here, total work is not the complete filling of the cistern. Only half of the cistern should be filled. So, half of work should be done by A, right? Therefore, work is half of work, right? Half of the cistern should be filled by A divided by efficiency of A. Efficiency is nothing but a work done per unit time. Here A takes 20 minutes of time to complete the work. Therefore, work by 20, right? Total work by 20 minutes is efficiency of A. Here we can cancel W and W, and we have half into this 20 goes to numerator. Yes. So we have time taken by A is 10 minutes, right? So that means to complete half of the cistern, A takes 10 minutes of time, right? Therefore, A takes 10 minutes. After 10 minutes, pipe A must be closed, right? After 10 minutes, pipe A must be closed. And in the remaining 17 minutes, B will fill the cistern completely. That's what the meaning of the question, right? Therefore, so the question is, so when the first pipe must be turned off so that the cistern may be just filled in 17 minutes. So after 10 minutes, right? It is after 10 minutes. Hence option A is the right answer. Question number 10. Two pipes A and B can fill a tank in 12 minutes and 15 minutes respectively. If both the pipes are opened simultaneously and the pipe A is closed after 3 minutes, then how much more time will take to fill the tank by pipe B? So here at first A and B, both the pipes, they start to fill the tank, right? So after few minutes, right? If both the pipes are open, the pipe A closed after 3 minutes. So after few minutes means here after 3 minutes, pipe A will be closed and only pipe B will fill the tank, the remaining portion of the tank, right? So here first we need to find what portion of the tank has been filled by both A and B in 3 minutes, right? Then what is the remaining portion, right? So to fill the remaining portion, what is the time taken by B? What is the time taken by B? Right? So how much more time will it take to fill the tank by pipe B? That's what the question is, right? So here, first let us consider the given information. A and B pipes can fill the tank in 12 minutes and 15 minutes, right? So the portion of the tank filled in 1 minute by A and B, right? In 1 minute, what portion of the tank will be filled by A and B together? Therefore, in 3 minutes, right? So, tank filled in 1 minute, by A and B together, right? So A can fill the tank in 12 minutes, the full tank in 12 minutes. Therefore, in 1 minute, A can fill 1 by 12, right? Again, we are using the concept of work, which is efficiency into time. Here, work is nothing but filling tank. Filling tank is considered as work, and 1 minute work is considered as efficiency, right? So work in unit time is called efficiency into the respective time, right? So here, to complete one work means the whole work, or you can consider it as W as the total work, right? W by 12 becomes the tank filled in 1 minute, or 1 as the whole work, 1 by 12 will be considered as tank filled in 1 minute by A, only A, right? So for, don't get confused, we'll consider it as W, right? So W by 12 is tank filled in 1 minute by A plus tank filled in 1 minute by B is W by 15, right? Total work by time is 1 minute work according to the formula. Therefore, tank filled in 3 minutes. Tank filled in 3 minutes by A and B, because right, for the first 3 minutes both A and B pipes fill the tank, right? Therefore, tank filled in 3 minutes by A and B is, so 3 into W by 12 plus W by 15, right? Since LCM is 60, so 60 and the numerator becomes 12 into 5 is 60, 15 into 4 is 60, right? Therefore, we have 5W plus 4W is 9W. 3 into 20 is 60. 9W by 20. So in 3 minutes, W by 20 by 9. Right? So 1 by 20 by 9 portion of the tank will be filled in 3 minutes. Right? So this portion, this which I am showing in a straight line, this portion is nothing but 1 by 20 by 9 portion. Right? 1 by 20 by 9 portion of the tank. What is the remaining portion? So, remaining portion of the tank. Remaining portion of tank to be filled is equal to, so if W is the total work to fill the tank, then W by 20 by 9 is already filled, right? Already filled. So on simplification, it is 20 by 9 W minus W by 20 by 9. So 20 by 9 minus 1 becomes 11 by 9 W whole divided by 20 by 9. Can cancel 9 and 9. Therefore, remaining portion of the tank to be filled is 11 by 20th portion of the tank. Right? For your better understanding, I'm just showing here. Right? So already filled portion is 1 by 20 by 9. If you consider whole tank as 1, if you consider the work to be done on tank as W, both are same. Anyway, you can consider. Then if you consider W, then it becomes W by 20 by 9. If you consider 1 as the whole tank capacity, then 1 by 20 by 9 portion of the tank has been filled by A and B, and the remaining portion is 1 by, right? So 11 by 20. 11 by, sorry, 20 by 11. 1 by 20 by 11, right? So here W by 20 by 11, right? Therefore, so here the question is, so how much more time will take to fill the tank by pipe B? So remaining portion 1 by 20 by 11, this portion of the tank will be filled by pipe B, right? So what is the time taken by it? Therefore, time is equal to work by efficiency, right? Here work is remaining portion, right? So W into 11 by 20. Therefore, time taken by B to fill the remaining portion is, so work by efficiency. Work is the portion of the tank to be filled. What is the remaining portion? So 11W by 20 whole divided by efficiency of B is total work by 15 minutes. Right? B takes 15 minutes. Therefore, its efficiency is W by 15. Right? Therefore, W and W will get cancelled. We have 11 into 15 by 20. So 5 into 3, 5 into 4. So we have 33 by 4. Right? Time taken by B is 33 by 4 minutes. So 4 into 8 is 32. So 8 hours 1 by 4 minute, 1 by 4 hour. So 8 and quarter means 8 hours, 8 minutes, right? 8 minutes, 1 by 4 minute is nothing but 15 seconds, right? Time taken by B is 8 minutes, 15 seconds, right? So in 8 minutes, 15 seconds, pipe B, right, can fill the whole tank, right? So option A is the right answer. Question 11. Three pipes A, B, and C can fill a tank from empty to full in 30 minutes, 20 minutes, and 10 minutes respectively. When the tank is empty, all the three pipes are opened. A, B, and C are filled with the chemical solutions P, Q, and R respectively. What is the proportion of solution R in the solutions in the tank after 3 minutes? So students will consider a tank, right? And three pipes A, B, and C, right? Right? So A can fill the tank in 30 minutes, B can fill the tank in 20 minutes, C can fill the tank in 10 minutes. So these are three pipes A, B, and C, right? So A can fill the tank with the solution P. B can fill the tank with solution R. These are the solutions, right? And pipe C can fill the tank with solution R. What is the proportion of solution R in the tank after 3 minutes? That means if three pipes are opened here, so what is the amount of solution, total solution P, Q, and R in 3 minutes? Right? In 3 minutes, what is the total amount of solutions in the tank? In that, what is the proportion of solution R in 3 minutes? Right? Right? So we'll consider, so in 3 minutes, right? So volume of solution R or part of solution R. Since the unit is not given, you can take part of solution R. What part of solution R be inserted into the tank, right? Part of solution R is equal to, so in 1 minute, 1 by 10th part of a solution can be filled into the tank, right? 1 by 10, because in 10 minutes, complete tank will be filled by solution R by pipe C, right? It is already given. Pipe C can fill the tank in 10 minutes, right? So C can fill solution R. Therefore, in 10 minutes, complete tank can be filled with solution R, right? Therefore, in 3 minutes, right? In 3 minutes, 1 by 10th part of the cistern can be filled, right? So filled with solution R. Therefore, part of solution R is 1 by 10th. Whereas in 3 minutes, right? This is for in 1 minute into 3 minutes. In 1 minute, 1 by 10th part of solution, which is R, into 3 gives in 3 minutes. So 3 by 10th part of solution can be filled. Therefore, in 3 minutes, part of solutions P, Q, and R. Solutions P, Q, and R together, right? So which is 3 into, in 3 minutes, right? Multiplied by 3 into, in 1 minute. So what part of the solutions P, Q, and R can be filled? So P's part is 1 by 30, Q's part is 1 by 20, and R's part is 1 by 10. into 3 gives in 3 minutes, right? So here LCM is 60. So 3 into 2, 2 into 3, then 10 into 6, right? Into 3 gives, so 3 into 20 is 60. So here 11 by 20 part, right? So it is 11 by 20, right? Part of the tank can be filled with P, Q and R, right? So all these three solutions in 3 minutes, right? Therefore, the question, what is the proportion of R? Therefore, proportion of R is equal to proportion of R in 3 minutes. In 3 minutes is equal to, so out of P plus Q plus R, right? The total part of the solutions, right? So part of R is so and so, right? Part of solution R is 3 by 10, right? So part of R is 3 by 10 part out of 11 by 20th part, right? 11 by 20th part. So what part of solution R, right, is filled in 3 minutes? Therefore, simplify it, 3 by 10 into 20 by 11. So it is 6 by 11, right? So 6 by 11 part of solution R is filled in the tank in 3 minutes. 6 by 11. Option C is the right answer. Students, if you want to practice such questions, please visit our website at www.examsnet.com. You can also download our app. The link is given in the description box. Question number 12. Two taps A and B can fill a cistern in 30 minutes and 60 minutes respectively. There is a third exhaust tap C at the bottom of the tank. If all the taps are opened at the same time, the cistern will be full in 45 minutes. In what time the exhaust tap C empty the cistern when full? So here we'll consider a cistern and two pipes A and B can fill the cistern in two different times, right? So whereas pipe A can fill the cistern in 30 minutes, whereas pipe B can fill the cistern in 60 minutes, right? So there is a third exhaust tap C. So we'll consider one exhaust tap C here. So it can empty the tank, right? It can empty the tank. So here it is given that if all the taps are opened, imagine all A, B, C are opened. So A, B, C can fill the tank, not empty the tank. So A, B, C can fill the tank in 45 minutes. So here students, if all the three pipes are working together, A and B, these two pipes will be filling the tank, whereas third tap will be emptying the tank, right? So this filling and emptying will take place simultaneously. But filling is more effective than the emptying, right? Therefore, so they take ABC, three pipes take 5 minutes of time. Whereas while filling the tank by A and B together, imagine C is not working, A and B are working. If A and B pipes are working, they take less time compared to the previous time, A, B, C when they are working, right? A and B take less time, right? If C is blocked, A and B only two pipes are working, they take less time to fill the tank, right? There is no pipe to empty the tank in the second case. Therefore, less than 45 minutes they take, right? So here the question is, in what time can exhaust tap C empty the cistern when it is full? Imagine the cistern is full and A and B are blocked. Only C tap is opened, right? So in how many minutes of time tap C can empty the cistern, right? For that, so first we need to consider in 1 minute. In 1 minute, so what portion of cistern can be emptied, right? So portion of cistern emptied. in 1 minute, right? So emptied by tap C, right? It is understood. So what portion of the cistern can be emptied in 1 minute, right? So to empty the full cistern, how many minutes are required will be the answer. For that, considering the given data, right? So to fill the tank A and B by A and B, right? So how many minutes are required? First, we need to consider. So based on the concept of work, which is efficiency into time, efficiency into time, the question is based on, right? Here the work is filling or emptying the tank, right? So it may be filling or empty the tank, right? Is equal to efficiency is nothing but 1 minute work. 1 minute work into total time, or work in 1 minute into total time gives the full work, right? So here in 1 minute, what amount of work can be done by A and B is called their effective or efficiency, total efficiency, right? Therefore, we'll consider 1 minute work of A and B together. It is so A can do some amount of work which is filling the tank in 30 minutes. So A's 1 minute work is 1 by 30, right? Plus B's 1 minute work is 1 by 60. Here 1 indicates the total work, which is nothing but filling the tank. In place of 1, you can consider even W as the total work. Then there were 1 minute works will be W by 30 and W by 60 respectively. Anyway, you can consider that. So 1 minute work of A and B together it is 1 by 30 plus 1 by 60. Whereas 1 minute work of A, B and C. A, B and C together. It is equal to, it is given that if all the taps are opened at the same time, the cistern will be full in 45 minutes. If all the taps are opened, they can fill the tank in 45 minutes. So total time is 45 minutes. So total work is 1 here. Therefore, their 1 minute work or the efficiency of ABC. ABC in scientific terms we can call it as efficiency of ABCs. By the formula it is work by time. If work is 1, totally ABC 3 pipes take 45 minutes of time, right, to fill the tank. So their 1 minute work becomes 1 by 45, right? So in the second case it includes pipe C, which is the process of emptying, right, also. Therefore 1 minute work of C. 1 minute work of C is equal to, so 1 minute work of ABC, which is 1 by 45, minus 1 minute work of A and B. It is 1 by 30 plus 1 by 60. Right? So now here 1 by 45 is less than 1 by the sum of these two. Right? So consider the difference here. So 1 by 45 minus here, this will be 3 by 60, which is 1 by 20, right? So this is greater. Just take the difference. 1 minute work of C will be 1 by 20 minus 1 by 45. Since the LCM is 180, right? The numerator becomes here 9 minus 4, which is 5 by 180, right? So 5 by 180. 1 by 180 by 5, which is nothing but 1 by 36, right? So 1 minute work of C is nothing but efficiency of C. Efficiency of C is equal to, here 1 is the total work. So what can be, this work can be filling the tank or emptying the tank, and 36 is total time. That means to empty the tank, here with respect to T, the work is emptying the tank, right? So to empty the tank, pipe C takes 36 minutes of time, right? That's what the meaning of the question, right? So pipe C takes 36 minutes of time to empty the tank or empty the cistern when it is full, right? Here the condition is it should be, the cistern should be full, right? So in that case, when A and B are blocked, pipe C, right? So tap C takes 36 minutes of time to empty the cistern. Hence option B is the right answer. Question number 13. Two pipes A and B can fill a water tank in 20 and 24 minutes respectively, and the third pipe can empty at the rate of 3 gallons per minute. If A, B and C open together filled the tank in 15 minutes, the capacity of the tank is. So here students, two pipes A and B can fill the tank. Right, here the time durations are different, so in 20 and 24 minutes respectively, right? Whereas the third pipe can C, we'll consider pipe C can empty at the rate of, so it can empty the tank in X minutes, say for example, right? Here the rate is 3 gallons per minute. For example, in X minutes, right, in 1 minute, right, 3 gallons per minute means in 1 minute, so it can empty 3 gallons, right, 3 gallons water, therefore in X minutes, right? So the question is, if A, B, C open together filled the tank in 15 minutes, the capacity of the tank is, right? So we need to find this answer, right? Capacity of the tank, right? So for that, here we'll consider A, B can fill the water tank in 20 and 24 minutes. And it is also given that A, B, C are open together. Open together means simultaneously if they start working together, right? So before going to the complete filling or emptying the tank, so what is their 1 minute work? We need to find that, right? What is their 1 minute work? So here students, the question is based on work is 1 minute work, which is nothing but efficiency into time. 1 minute work into time, right? As in the previous cases. Here also, we are taking 1 minute work of pipe A, right? 1 minute work of pipe A is, if 1 is the total work, 1 by 20 will be 1 minute work of pipe A. Whereas 1 minute work of pipe B is 1 by 24, because pipe B takes 24 minutes to fill the tank, right? Therefore, its 1 minute work is 1 by 24th part of the total work, right? So here 1 minute work of C it is not given directly, right? We have to find, and their total 1 minute work can be taken easily by taking 15 minutes work, right? They can complete the total work in 15 minutes, A plus B plus C together, right? Therefore A, B and C's 1 minute work, 1 minute work is equal to the total time is 1, if you consider 1 as the total time, divided by, right, 1 as the total work, not the time. If 1 is the total work by total time gives their 1 minute work, right? So total time is 15 minutes, right? Total work by total time gives their 1 minute work. So A, B, C together they take 15 minutes. Therefore, the total time is 15 minutes, and 1 by 15 is their 1 minute work. Therefore, 1 minute work of C, pipe C. So 1 minute work of A, B, C. So A plus B plus C, right? Their 1 minute work, 1 minute work minus 1 minute work of A and B, pipe A and B, right? So 1 minute work of A plus B plus C is 1 by 15 minus 1 minute work of A and B. So just add these two, right? 1 by 20 plus 1 by 24. Simplify it, you will get 1 minute work of C. 1 by 15 minus, here the LCM is 24 into 5, which is 120. So 20 into 6 plus 24 into 5. So 1 by 15 minus 11 by 120. So again 120 is the LCM here. So 15 into 8, right? Am I right? So 8 minus 11, right? Since 1 minute work of A plus B is greater than A plus B plus C, it is understood that A, B, C, they take more time, right, when compared to A plus B. Because so when A and B they start working, C will be emptying the tank, right? So more time is required to fill the tank when all the pipes are working, right? Because at the same time C is taking out the liquid here, water here out of the tank. Therefore, more time is required, right? So here it is 3 by 120. Don't consider the negative sign. We are just considering the difference between their 1 minute work, right? Work cannot be a negative work. Therefore, 1 minute work of C. 1 minute work of C is 3 by 120. If 1 is taken as the total work, denominator becomes 120 by 3. Right? Therefore, 1 by 40 is 1 minute work of C. That means C takes time taken by C is 40 minutes. 40 minutes. And it is given that rate of, so C can empty at the rate of 3 gallons per minute. For every minute it can empty 3 gallons, right? So to empty the tank, how many minutes are required? 40 minutes are required, right? Therefore, in 1 minute, right? So amount of water taken out from C is 3 gallons, right? Therefore, in 40 minutes, right? Therefore, it is 3 gallons into 40 minutes. So, 120 gallons. So, 120 gallons is the total capacity of the tank, right? So, because C takes X minutes, which is 40 minutes to empty the tank. To empty means it has to take out all the water from the tank, out of the tank, right? In 1 minute, it can take out 3 gallons, means in 40 minutes, it can take out 120 gallons of water, right? Therefore, this 120 gallons is nothing but capacity of the tank. Capacity of the tank. That's what the question is, right? Have capacity of the tank in the sense, so what amount of water can be taken out if the tank is full, right? Therefore, so 120 gallons. So option B is the right answer. Question number 14. Pipes A and B can fill a tank in 32 and 28 minutes respectively. If pipe B was opened 8 minutes after opening pipe A, find the time taken by both to fill the remaining tank. So here students, for first 8 minutes, we'll consider 8 minutes, right? So only pipe A was opened, right? So we'll consider pipe A for first 8 minutes, right? And after 8 minutes, both A and B continue to work. Both the pipes continue to fill the tank, right? So what is the time taken by A and B, both the pipes, right, to fill the remaining tank? Only to fill the remaining part of the tank, what is the time taken by A and B? That we need to consider. So for that, first we need to consider work done by A. Work done by A means, so amount of work done by A to fill the tank, right, in 8 minutes. 8 minutes. So for that, we need the information that pipe A alone can fill the tank in 32 minutes, right? Therefore, so pipe A is 1 minute work. Pipe A is 1 minute work. is equal to, it is nothing but in scientific terms we call it as efficiency, right? Efficiency is always work by time. We all know that, right? So pipe A's 1 minute work is equal to total work. If you consider it as 1, or W can also be taken as the total work, right? So 1 by, so pipe A takes 32 minutes. So, right? Pipe A's 1 minute work is 1 by 32 of total work, or 1 by 32nd part of the work can be done by pipe A in 1 minute, right? If you take W as the total work, A's 1 minute work becomes W by 32, right? So both the ways you can consider. Therefore, pipe A is 8-minute work, because for first 8 minutes only pipe A is opened, right? Therefore, A's 8-minute work. 8-minute work is equal to 8W by 32, right? So in other words, it is W by 4, right? So A can do 1 by 4th part of the total work. If total work is W, so quarter of the work will be done by pipe A in 8 minutes, right? What is the remaining work? Remaining work is the remaining 3 by 4th of work, right? So total work is W minus 1 by 4th part of the work has already been done by A. Therefore, the remaining work is 3 by 4 of the total work is remaining, right? This work has been done by pipe A and B. Here work is filling the tank itself is the work, right? So this 3 by 4th part of the work, right, will be done by pipes A and B, right? Therefore, remaining work is equal to, so total work minus first part of the work, it is 3 by 4th part of the work. According to the concept, work is efficiency into time. Therefore, 3 by 4th, we are focusing only on the remaining part of the work, right? Because we need to find time taken, right, to do the remaining part of the work, right? Therefore, 3 by 4th of the work is equal to efficiency. Here, efficiency of both pipes A and B, right? Efficiency in general terms, A is 1 minute work plus B is 1 minute work. A is 1 minute work plus B is 1 minute work. 1 minute work. It is nothing but their efficiencies into time taken by them. Time taken by pipes A and B. That we need to find now, right? A's 1 minute work is W by 32. Whereas B's 1 minute work is W by 28, because B takes 28 minutes, right? So W by 32 plus W by 38 is their 1 minute work into time taken by pipe A and B to fill the tank, to fill the remaining part of the tank, which is 3 by 4th of the work, right? Therefore, simplify it. Here, if you take, sorry, this is 28, directly take 32 into 28 as the LCM. So numerators become 28W plus 32W. So the simplification will be easy, right? So time taken by A and B pipes is equal to, simplify it, 3 by 4th of work into 32 into 28 divided by sum of 28 plus 32 is 60W. So that we can cancel W and W, and simplification part 4 into 8, right? So 3 into 20, so 4 into 2, 4 into 5. So we have 28 into 2, which is 56 by 5 as the total time taken by pipes A and B at last, right? So 56 by 5 is nothing but 5 into 11 is 55. So 11 integer 1 by 5 minutes is time taken by pipe A and B, right? So time is 11 integer 1 by 5 minutes, right? So remaining part, the remaining 3 by 4 part of the work has been done by two pipes, right? So A and B to fill the tank, and the time taken by them is 11 integer 1 by 5 minutes. Option D is the right answer. Question number 15. Three pipes A, B, and C are attached to a cistern where A and B are inlet pipes and C is a waste pipe. Time taken by A, B, and C individually to fill the cistern is 11, 10, and 15 minutes respectively. Find the approximate time taken by all of them together to fill the cistern. So here students will consider a cistern, right? So which has two inlet pipes A and B, right? A and B, and an outlet pipe C. Right here, time taken by pipe A to fill the cistern is 11 minutes, whereas individual time taken by B to fill the cistern is 10 minutes, whereas C pipe, since it is an outlet pipe, right? C is a waste pipe. It is an outlet pipe. So time taken by C to do the work. C cannot fill the cistern, right? Pipe C cannot fill the cistern. It's a waste pipe. Therefore, so C cannot fill the cistern. So it can empty the cistern in 15 minutes. If the cistern is full, so pipe C can empty the cistern. Whether it is filling the cistern or emptying the cistern, the work will be same, right? So the question is based on the work, which is equal to efficiency into time. Efficiency into time. Here work is nothing but filling the cistern or taking out water from the cistern, right? Therefore, efficiency, here work is filling or emptying, right? Efficiency is nothing but, since the time is in terms of minutes, 1 minute work is called efficiency, right? So here work is filling or emptying. So in 1 minute, what amount of water is stored, filled, is called efficiency of that particular pipe into total time taken by the pipe, right? Gives the total work, right? Here, pipe A can individually take 11 minutes of time, right, to fill the cistern. So to find the time, first we'll consider work done by each pipe in 1 minute, which is nothing but efficiency of each pipe, right? So 1 minute work of pipe A. Work of pipe A is equal to, since efficiency is work by time, if you consider W as work, or you can consider 1 as a whole, 1 as the total work, right? And part of 1 is nothing but part of the work, right? So 1 minute work of A is W by A takes how much time? 11 minutes of time. Therefore, it's a pipe A's 1 minute work is W by 11, right? That means 1 by 11th part of total work. Whereas 1 minute work of B, pipe B is W by, B takes 10 minutes of time totally. Therefore, W by 10 becomes its 1 minute work. Whereas 1 minute work of C, pipe C is W by 15. 1 by 15th part of total work can be done by C in 1 minute. Right? So here we need approximate time taken by all of them together to fill the cistern. If all the pipes start working together, right? If all the pipes start working together, we'll consider sum of their 1 minute work, right? Therefore, we'll consider if all A, B, C start working together, right? So we have to consider sum of their one minute work, right? So W by 11 plus W by 10 plus W by 15, sum of their 1 minute work. So here W by 15, since the third work is emptying the tank, just subtract this W by 15, right? C cannot fill the tank, it can empty the tank, therefore minus W by 15, right? Simultaneously filling and emptying will take place, right? So here take first two terms where the LCM is 110. So the numerators become 10W plus 11W minus W by 15. Right? Here So 110 into 3 is 330, which is also a multiple of 15, right? So LCM is 330 and the numerator becomes, so 110 into 3, therefore, so the numerator is 21W into 3 is 63W minus 15 into 22 is 15 to 22 is 330, right? Therefore, numerator becomes 22W. Therefore, we have 41W by 330 is 1 minute. 1 minute work of A, B, C. A, B, and C. Right? 1 minute work of A, B, C is nothing but efficiency. It is always work by time. Total work by time. So let us express the numerator as the total work, which is W, and the denominator becomes 330 by 41. Therefore, the total time taken by ABC, total time taken by ABC is 330 by 41, right? 330 by 41. So here, it is given that find the approximate time. We'll simplify the total time, right? Therefore, time taken by ABC is 330 by 41. So we have 41 into 8, which is 328. So 8 integer 2 by 41. So approximate value is 9 minutes. Right? Time taken by pipes A, B, C, right? To fill the cistern is 9 minutes approximately. Option B is the right answer. Question number 16. A cistern is connected with 3 pipes A, B, and C, where A and C are inlet pipes and B is a waste pipe. A and B were opened for 10 minutes, then B was closed and C was connected to A to fill the cistern. Find the time taken by pipes A and C together to fill the remaining portion of the cistern. So students will consider a cistern which has 2 inlet pipes A and C. Right? A and C are inlet pipes and B is an outlet pipe. Right? So here A and B were opened for 10 minutes. For 10 minutes, A and B were opened. Right? After 10 minutes, C was connected to A. So A and C were opened. Right? So here we need to find time taken by pipes A and C to fill the remaining portion. This is the remaining portion. This is the first part of the cistern. Right? Here we need to find time taken by pipes A and C. For that, here to find this, we need individual time taken by each pipe to fill the cistern, right? Then only we can find such times, right? If individually A takes so and so minutes, right? For example, 40 minutes, C takes 35 minutes, like that. Then only we can find the time taken by 2 or more pipes, right? When they are connected to each other, when they were opened simultaneously, right? When individual times are given, then only we can find the remaining time here. Therefore, for this question, the data is inadequate, right? So option D is the answer, right? So individual time should be given. Then only we can find the time taken by pipes A and C to fill the remaining portion, right? Therefore, here the data is inadequate. We cannot solve this question, right? Option D is the answer. Question number 17. A tap can fill a tank in 12 hours, whereas another can empty it in 18 hours. If both the taps are open simultaneously, how much time will the tank take to fill? So here students, one tap can fill the tank in 12 hours, right? So we'll consider tap A, and another tap can empty the tank in 18 hours. 18 hours. Let it be tap B. Right? If both the taps are opened simultaneously, so when the word simultaneously opened 2 or more taps, we need to consider their 1 hour work or unit time work, which is called efficiency. We have to consider their efficiency, means work done by the respective type per unit time is called efficiency. Right? Here efficiency is always expressed in terms of work and time. Right? once the efficiency is expressed, efficiency is nothing but unit time work. Here in this particular case, 1 hour work of each pipe, right? When efficiency is expressed or their 1 hour work is expressed in terms of work and time, right? Based on the formula, we can easily find the total time taken by the pipes, right? Because efficiency depends on time, right? Therefore, so we'll consider their 1 hour work, right? Since first pipe can take 12 hours of time to fill the tank. Therefore, 1 hour work of pipe A. 1 hour work of pipe A is total work divided by time. Here 1 hour work is nothing but efficiency, right? Total work by time. So if you consider W as the total work, here work is nothing but filling the tank or emptying the tank, right? So here in this particular case, to fill the tank, right? To fill the tank, pipe A takes 12 hours of time. Therefore, in 1 hour, pipe A can fill W by 12, right? So, pipe A can do W by 12 amount of work, right? So, which is nothing but 1 by 12th of total work. Whereas, 1 hour work of pipe B, 1 hour work of pipe B. Here, another pipe can empty the tank, right? It cannot fill the tank. It can empty the tank in 18 hours. Here, the total work is same. Whether it is filling or emptying the tank, work will be same, right? So here it can empty the tank in 18 hours. Therefore, 1 hour work of pipe B is W by 18, right? If both the taps are opened, so we'll consider 1 hour work of pipe A plus 1 hour work of pipe B, because both the pipes, they start to work together, right? Therefore, sum of these two. So 1 hour work of pipe A plus 1 hour work of pipe B. Both the taps are opened simultaneously. So the 1 hour work becomes double. It is not plus here. We cannot add their 1 hour work because here 1 hour work of B is with the negative sign. B cannot fill the tank, so it can empty the tank. Therefore, W by 12 minus W by 18, right? Therefore, since the LCM is 36, so 3W minus 2W will be the numerator. So W by 36 is 1 hour work of pipe A and pipe B, right? Therefore, 1 hour work is nothing but efficiency of A and B is nothing but the total work. According to formula, work by time is efficiency. Therefore, time taken by taps A and B is equal to 36 hours. The unit is in terms of hours, right? Therefore, option A is the right answer. So, how much time will the tank take to fill? So, if both the taps are opened simultaneously, so 36 hours. So, both the taps take 36 hours to fill the tank. Option A. Question number 18. A and B together can fill a tank in 4 hours, whereas C alone can empty it in 8 hours. Working together, all the three can fill the tank in how much time? As in the previous example, previous question, here also, two pipes can fill the tank, right? Two pipes can fill the tank, whereas the third pipe can empty the tank, right? These pipes be A, B, and C. Right here, first two pipes A and B together, they take 4 hours of time to fill the tank, not individually, right? Together the two pipes can take 4 hours, whereas the third pipe takes 8 hours of time to empty. Third pipe alone will take 8 hours of time to empty the tank, right? So here, working together, when all the three pipes are opened together, right? So what is the time taken by three pipes to fill the tank, right? Not to empty the tank. So three can fill the tank in how much time, right? So as in the previous example, here also we are considering their 1 hour work, 1 hour work of each pipe, right? So for that, we will consider the concept of work is equal to efficiency into time. Efficiency into time. Efficiency is nothing but 1 unit work. Here unit is hour, right? 1 hour work into time, right? So here 1 hour work of both A and B pipes should be taken, because A and B together they take 4 hours of time, right, to fill the tank. So we'll consider 1 hour work of A plus B. Together it is total work W by, together they take 4 hours of time. Therefore 1 hour work becomes W by 4. Right? And the third pipe can empty the tank. Therefore, 1 hour work of C. 1 hour work of C is the total work divided by. So it is the, here the work is emptying the tank, right? Not filling the tank. Here emptying the tank needs the same amount of work, right? So here W by 8. Both emptying and filling the tank will require same amount of work. Therefore, W is same, right? So 1 hour work of C is W by 8. If all 3 pipes are opened, if A, B, C are opened, their 1 hour work, 1 hour work becomes 1 hour work of A plus B, which is W by 4. Right? W by 4 is A and B's 1 hour work. Whereas C will be emptying the tank. Here water is passing through pipe C out of the tank. Therefore, C's 1 hour work with negative sign should be considered, right? W by 8, right? Since water is going out of the tank through C. Therefore, here LCM is 8. So, numerator becomes 2W minus W, which is W by 8. So, 1 hour work of ABC, right? Their 1 hour work is W by 8. 1 hour work is nothing but efficiency of ABC. Together it is work by time. Time taken by ABC, right? Therefore, 8 hours of time. A, B, C pipes together they take 8 hours of time. Option C is the right answer, right? Working together, all the 3 pipes can fill the tank in 8 hours. Why do they require more time compared to A and B? Here, when A and B, so together they can fill the tank in 4 hours. When C is opened along with A and B, they require more time, because water will be going out of the tank at the same time, right? Because C can empty the tank, right? Therefore, they require more time, which is 8 hours. Option C is the right answer. Question number 19. A certain tank can be filled by pipes A and B separately in 4 and 5 minutes respectively, whereas pipe C can empty it in 3 minutes. How long will it take to fill or empty the 4/5 full tank if all the 3 pipes start together? So very similar question to the previous one. Here we'll consider 3 pipes A, B and C, where A and B can fill the tank, right, in 2 different time durations. We'll consider pipe A can fill the tank in 4 minutes, whereas pipe B can fill the tank in 5 minutes. Whereas one more pipe C can empty the tank in 3 minutes. We'll consider pipe C here, right? So if all the pipes start working together, if all 3 pipes are opened, right, what is the time taken to fill 4/5 of full tank, right? Not full tank, 4/5 means not full tank, somewhere here. What is the time taken to fill or empty? Here work done to fill is equal to work done to empty, right? So same amount of water will be filled, right? And same amount of water will be taken out of the tank. Here work is same, right? Work to fill is equal to work to empty. right? So here, what is the time required to fill 4/5 of tank? Right? If all the three pipes start together, if all three pipes are opened, right? Again, the concept is, or the question is based on the concept, work is equal to efficiency into time. Right? Here, efficiency is nothing but a unit work. That is 1 minute work. Work done in unit time, right? Into time taken is the work, right? So first let us consider full work, that is full tank work, right? Work required to fill the tank completely as W, right? For that, we'll consider 1 minute work of each pipe, right? So 1 minute work of 1 minute work of pipe A. If W is the total work, W by 4 becomes 1 minute work of A, whereas 1 minute work of pipe B becomes W by 5. Whereas 1 minute work of pipe C is W by 3. Right? So to take out water from the tank, W by 3 amount of work is required per minute. Right? So here, if all three pipes start together, if all pipes are opened, their 1 minute work becomes sum of their 1 minute work. So which is W by 4 plus W by 5, right? Since pipe C is open to empty the tank, right? Therefore, minus W by 3, right? Therefore, here the LCM is, so 1 minute work in that LCM is 20. So it is 5W plus 4W, and the last term is minus W by 3, right? So 9W by 20 minus W by 3, where LCM is 60. So 9W into 3, since 20 into 3 is 60, 27W. 9W into 3 is 27W minus 3 into 20 is W, so it becomes 20W. Hence, we have 7W by 60, right? So, 1 minute work of all three pipes, right, is equal to 7W by 60. So, in terms of whole work by 60 by 7 is their 1 minute work, right? Here, the question is to fill 4/5 of a full tank. 4/5 of full tank means, so in place of W, we need 4/5 of W. Therefore, so efficiency of ABC, which is 1 minute work, right, of A, B and C pipes is equal to W by 60 by 7. So when this equation is multiplied by 4 by 5, because we need 4/5 of the total work, right? So LHS becomes a 4 by 5 into 1 minute work, which is 1, is equal to 4 by 5 into W divided by 60 by 7, right? Therefore, 4/5 of work, which is 4/5 of W is equal to 60 by 7 into 4 by 5, right? So 5 into 12, so we have 48 by 7, right? 48 by 7, and so 4/5 of work is equal to 48 by 7. Therefore, come back to the question. So if all three pipes start together, time taken to fill the tank is equal to how much? 48 by 7. 48 by 7 minutes to complete 4/5 of the work. So into 1 minute work, right? So it is equal to, work is equal to efficiency into time, right? Efficiency is how much? 1 minute work into 4/5 into time is 60 by 7. Together it is 48 by 7. So which is nothing but 7 into 6. 6 integer 6 by 7 minutes. 6 integer 6 by 7 minutes are required, right? Option C is the right answer, right? Option C. Question number 20. A cistern is connected with two pipes. An inlet pipe can fill the cistern in 40 minutes and an outlet pipe can empty it in 2 hours 40 minutes. Both the pipes were opened together before the outlet pipe was closed after 12 minutes. Find the time taken by the inlet pipe to fill the remaining part of the cistern. So here students, so cistern has two pipes, inlet pipe, let it be A, and an outlet pipe, let it be B, right? Inlet pipe can fill the cistern in 40 minutes, whereas outlet pipe takes 2 hours 40 minutes. So which is 120 minutes plus 40 minutes, which is 160 minutes, right? So here outlet pipe was closed after 12 minutes. That means for first 12 minutes, right, both A and B pipes were opened. After that, outlet pipe was closed. Only pipe A will be opened, right? Time taken by inlet pipe to fill the remaining part of the cistern. So to fill the remaining part, so that means for 12 minutes, if this much part is filled already, for 12 minutes, so to fill the remaining part of the cistern, what is the time taken by which pipe? Inlet pipe A, right? Remaining part will be filled by inlet pipe A, right? For that, first we need to consider, so work done in 12 minutes by these two types A and B, right? So the steps are, first we need to consider work done. Work done is nothing but filling the cistern itself is the work done, right? Work done in 12 minutes by the respective pipes, right? For the first 12 minutes, both the pipes were opened. Therefore, work done by A and B pipes in first 12 minutes. Next, we need to consider the remaining work. What is the remaining work? That we need to find. Then to do this remaining work, right? So pipe A, inlet pipe takes how much time? Time taken by A to do the remaining work. To do the remaining work. These are the three steps in this question, right? So let us go for solution. First, the question is based on the concept work is equal to efficiency into time. Here, efficiency is nothing but 1 minute work into the total time. Total time, right? So we'll consider 12 minutes work of A and B. For that, we need 1 minute work of pipe A and 1 minute work of pipe B, right? So we'll consider first step, 1 minute work of A, work of pipe A, right? So pipe A takes 40 minutes of time to fill the tank. Therefore, 1 minute work of A is work by 40. Whereas 1 minute work of B, outlet pipe B is total work by, it takes 2 hours 40 minutes. 2 hours means 120 minutes plus 40 minutes is 160 minutes, right? 1 minute work of B is W by 160, right? And both the pipes were opened for 12 minutes, right? So therefore, together we'll take 1 minute work of A plus B. A and B will take. No need to add. Here, the pipe, second pipe is outlet pipe. Therefore, W by 40 minus W by 160. Since the second pipe is outlet pipe, pipe cannot fill the water, right? Pipe B cannot fill the water. So it can empty the tank, empty the cistern. Therefore, we have to take the negative sign for pipe B, right? This is 1 minute work of A and B. Therefore, A and B were open for 12 minutes. So 12 minute work of A and B. So 12 into, so W by 40 minus W by 160. Since 160 is the LCM, numerator becomes 40 into 4. So it becomes 4W minus W. Right? So 12 into 3W by 160 is 12-minute work of A and B. Right? Still you can simplify. So 4 into 3, 4 into 40. So 9W by 40 is 12-minute work of A and B. Right? What is the remaining work? Here remaining work has been done by pipe A, inlet pipe A, right? After 12 minutes, so outlet pipe was closed, right? Therefore, we'll consider remaining work. Remaining work is equal to, so total work W minus first 12 minutes work. What is first 12 minutes work? Which is 9W by 40 is first 12 minutes work, right? 9W by 40. So we have 40 as LCM. So 40W minus 9 is 31W. So remaining work is 31W by 40. So this remaining work has been done by A, right? Therefore, 31W by 40 is equal to, so 1 minute work of A. According to the formula, work is 1 minute work into time. Right? We have discussed already, right? 1 minute work into total time according to this formula. Therefore, 31W by 40, that is remaining work is equal to 1 minute work of A. Why do we take A here? Because remaining work has been done by A into time taken by A. We need time taken by A here, right? Since 1 minute work of A is W by 40, W by 40 into time taken by A is equal to 31W by 40. So we can cancel 40, 40, W and W. Therefore, time required to fill remaining part of the cistern is 31 minutes. Right? So this part which I am showing here, right? Time required to, right? This remaining part of the cistern to fill that, pipe A requires how much? 31 minutes of time, right? Whereas A plus B together they can fill how much part? The first part, right? So first part of the cistern in 12 minutes, right? Whereas to fill the remaining part, which is 31W by 40, it is the remaining part of the cistern. To do that, pipe A requires 31 minutes of time. Hence, option D is the right answer. Question number 21. A cistern which could be filled in 9 hours take 1 hour more to be filled owing to a leak in its bottom. If the cistern is full, in what time will the leak empty it? So here students will consider a cistern and a hole at the bottom of the cistern. And cistern could be filled in 9 hours. We'll consider a pipe, right? So cistern could be filled in 9 hours. In ideal case, right? So we will consider two cases. In ideal case, time taken to fill the cistern is 9 hours, right? So, but it takes 1 hour more to be filled owing to a leak in its bottom. Because of the leak in its bottom, it takes 9 plus 1 hours, right? Therefore, in real case, time taken will be 9 plus 1 hours, which is 10 hours, right? Here the question is, if the cistern is full, for example, if it is full, in what time will the leak empty it? So here, in what time, right, this leak will empty the cistern. For that, we need to consider the unit time work of this leak, not the pipe, right? So that means 1 hour time. Here unit time is in terms of hour. 1 hour work of this hole or the leak, leak or hole. 1 hour work of hole should be considered. 1 hour work is nothing but the efficiency of the hole. Should be expressed in terms of the total work by time. Then only we'll consider, we can get the answer for the given question. In what time the leak will empty the cistern, right? So this time, in this time, right, the leak will be, so that means time taken by the leak to empty the cistern, right? First, we need to consider 1 hour work of leak, right? So for that, we need the ideal cases and real cases here. So ideally, the cistern, or it may be a pipe, takes 9 hours time to fill the cistern, right? If filling the cistern itself is the work here, therefore we'll consider work is nothing but W is nothing but filling the cistern with water, right? Is nothing but the work, right? So 1 hour work, 1 hour work to fill the cistern is a total work by 9 in ideal case. But in real case, time is 1 hour more, right? Therefore, in real case, 1 hour work will be total work by 10 hours, right? Since work is same here, total work by 10 hours, right? Therefore, 1 hour work of leak or hole. Because of leak, it takes 1 hour more time, right? Therefore, 1 hour work of leak is equal to W by 9, right? Minus W by 10. Since numerator is, sorry, here numerator is same, denominators are different here, right? So if the term has less denominator, its value will be more compared to the another term. So W by 9 is greater than W by 10 here. Therefore, this difference gives 1 hour work of leak, right? Therefore, here 90 is the LCM, numerator becomes 10W minus 9W. Therefore, W by 90 is 1 hour work of leak, right? 1 hour work of this hole is W by 90. 1 hour is nothing but efficiency of hole. Efficiency of hole is equal to W is the total work. So work to empty the cistern here. It may be filling or emptying the cistern. Work is same. So work to empty the cistern divided by 90, right? Here the time unit is hours, right? Therefore, to do the work, to empty the cistern, this hole or leak takes 90 hours of time, right? Therefore, come back to the question, if the cistern is full, in what time will the leak empty it? Leak will empty the cistern in 90 hours. Option C is the right answer. Students, if you want to practice such questions on pipes and cisterns, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 22. 3 pipes A, B, and C can attach to a cistern such that A and B can fill the cistern in 7 and 14 hours respectively, whereas C can empty it in 10 hours. If all the 3 pipes are opened simultaneously, find the time taken by them to fill the cistern. So very easy question. So we'll consider a cistern and 2 inlet pipes, right? So 2 inlet pipes, A and B, right? So here A and B can fill the cistern. Therefore, these two are inlet pipes. A takes 7 hours of time to fill the cistern individually, whereas B takes 14 hours of time to fill the cistern individually, right? Whereas C can empty the cistern. We'll consider an outlet pipe C, which can empty the cistern in 10 hours individually, right? If all the 3 pipes are opened simultaneously, we need to find time taken by them to fill the cistern. So students, so when all the 3 pipes are opened, we have to consider their 1 hour work. right? Unit time work. Here time is expressed in terms of hour. So we have to consider their 1 hour work, right? So that means 1 hour work of A, B, C, all the three pipes. Their 1 hour work is equal to total work divided by time taken by them. 1 hour work is nothing but their efficiency. Since work is equal to efficiency into time, therefore efficiency of A, B and C is equal to work by time, right? So if 1 hour work, the sum of their 1 hour work, if you calculate that, so then you can easily get total time taken by them, right? So we'll consider their 1 hour work individually, in individual case, right? Then you can take sum of their 1 hour work. So here 1 hour work of 1 hour work of pipe A, right? To do W amount of work. So here work is filling the cistern, right? Work is nothing but filling cistern is itself is the work, right? So 1 hour work of A is W by A takes 7 hours of time, right? In 7 hours, pipe A can do W amount of work, right? That is filling the cistern. Therefore, in 1 hour, right? So what amount of work can be done by A? It is W by 7, right? Whereas 1 hour work of pipe B. Pipe B is total work by how much? 14 hours, right? This is a small amount of work done by B, which is in 1 hour, right? W by 14. Whereas 1 hour work of C. Pipe C can do W by 10. So 1 by 10th of total work can be done by C in 1 hour, right? If all the three pipes are opened, right? If all pipes are opened, their 1 hour work, then their 1 hour work is equal to, so A's 1 hour work is W by 7, right? B is also an inlet pipe. B can fill the water, therefore plus W by 14. Whereas C can empty the water, right? Empty the cistern, therefore we have to use negative sign minus W by 10. Here in first two terms 14 is the LCM and the numerator becomes 2W plus W, which is 3W minus W by 10, right? So here we have 14 into 5, which is 70, right? 70 is the LCM and the numerator becomes 15W minus 7W. Therefore, we have 8W. Yes, 8W by 70. So this is 1 hour work. So we will take W in the numerator. Denominator becomes 70 by 8. Right? So 1 hour work of all the three pipes is nothing but their efficiency is equal to the total work. Total work, W is nothing but the total work divided by total time. That means A, B, C, three pipes take 70 by time is equal to 70 by 8 hours of time to fill the cistern. 70 by 8 means 8 integer, 8 into 8 is 64. 8 integer 6 by 8. Still you can simplify 8 integer 2 into 3, 2 into 4, right? So 8 integer 3 by 4 hours, right? So all the three pipes will take 8 integer 3 by 4 hours of time to fill the cistern. Option A is the right answer. Question number 23. Two inlet pipes A and B can individually fill a tank in 1 hour and 40 minutes respectively. Both the pipes are opened simultaneously, but pipe B got burst 4 minutes before the schedule to fill the tank completely. The tank is filled by pipe A alone. Find the total time taken by pipe A to fill the tank. So here students, two inlet pipes will consider, right? So both the pipes are opened simultaneously, right? But before the scheduled time, say for example, if the scheduled time is so and so minutes, right? So 4 minutes before the scheduled time, pipe B got burst, right? Pipe B got burst. Therefore, pipe A alone has to work for the remaining minutes to complete the task. Here, the complete the task means to fill the tank, right? Therefore, for first few minutes, we'll consider for first t minutes, both the pipes are opened, A and B pipes are opened, and for the last few minutes, only pipe A is opened, right? Because pipe B got burst, right? So therefore, so here the question is, find the total time taken by pipe A to fill the tank. So for first t minutes, time taken by A is equal to first t minutes, right? Plus along with the pipe B, so pipe A also takes first t minutes, right? Plus last few minutes, right? So this gives the total time taken by A, right? So to find that, so we'll consider their individual times, right, to complete the work here. What is work? Work is filling the tank, right? So here we'll consider total work as, let total work be W. So W is nothing but filling the tank fully is considered as the total work, right? To complete this work, pipe A takes 1 hour of time individually, right? So in 1 hour, pipe A can fill the tank, pipe A can do the total work. Therefore, in unit time, since the time is in terms of minutes here, so 1 hour will be considered as 60 minutes, right? So in unit time means in 1 minute, what amount of work will be done by pipe A, right? That we'll consider as 1 minute work of pipe A is equal to total work W by 60 minutes. Since work is equal to efficiency into time, we are using this concept. Efficiency is nothing but work per unit time, right? Which is 1 minute work. 1 minute work into total time is considered as the total work, right? Therefore, 1 minute work of pipe A is equal to total work W by the total time is 60 minutes, right? Whereas 1 minute work of pipe B is total work W by 40 minutes, right? So when these two pipes work individually, they take the time 60 minutes and 40 minutes respectively. Therefore, their individual 1 minute work will be W by 60 and W by 40 respectively. So moving further, both the pipes are opened simultaneously. If both the pipes start working together, we'll consider their 1 minute work, right? So if both the pipes, both A and B are opened, their 1 minute work, A and B pipes 1 minute work will be is equal to W by 60 plus W by 40. So by taking LCM, so here LCM is 120, numerator becomes 60 into 2, which is 120. So 2W plus 3W. Hence we have 5W by 120. So W by 120 by 5 is 24. W by 24 is 1 minute work of A and B. So we'll take it as A plus B, right? 1 minute work is nothing but efficiency. Efficiency of A and B together is W is total work by 24 is total time. According to the formula, total work by total time is efficiency, right? So A and B pipes take totally 24 minutes of time to complete W amount of work. This is in ideal case. But in reality, pipe B got burst before 4 minutes, right? Therefore, A and B pipes, they took actual time 24 minus 4 minutes, which is 20 minutes, right? Therefore, so we'll mention here pipe B got burst before 4 minutes. 4 minutes. Therefore, actual time taken by A and B, is equal to 24 minus 4 minutes, which is 20 minutes. So at first, for T minutes, A and B pipes are opened. T is equal to 20 minutes. After 20 minutes, pipe B got burst, right? In ideal case, both the pipes take 24 minutes of time. But in real case, both the pipes opened for only 20 minutes, right? Right? Therefore, after 20 minutes, B got burst. And in the remaining timing, what is the remaining time? In that, pipe A completes the task, right? That we need to find. To find the remaining time, we have to consider remaining work. Remaining work is equal to, so if you have taken W as the total work, right? So total work W minus already done work. So what is already done work? So W by 24 is already done work, right? Do you agree? W by 24 in first T minutes, W by is it W by 24? 1 minute. So work done by A and B in first 20 minutes. It is not that fully W by 24. So it is W by 24, right, into 20 minutes. It is their 1 minute work, right? So A and B's 1 minute work is W by 24. But A and B worked for 20 minutes. Therefore, into 20, right? Therefore, so you can mention here. Therefore, A and B's 20-minute work. 20-minute work is W into 20 by 24, right? Therefore, you will get W minus here 4 into 5, 4 into 6. Therefore, W minus 5W by 6. So, we have W by 6 as the remaining work, right? Therefore, so we need time taken by A. Time taken by A to complete remaining work. Remaining work is equal to, how do you find time taken by A to complete remaining work? Since work is equal to efficiency into time, so time is equal to work by efficiency, right? So is equal to, so work is here remaining work by efficiency of A. Here efficiency is nothing but 1 minute work of A, right? 1 minute work of pipe A, because remaining work has been done by only pipe A, right? What is remaining work? Remaining work is W by 6 and 1 minute work of pipe A. So it is W by 60, right? W by 60 according to the formula. Yes, time taken by A to complete remaining work is, here W and W will get cancelled. We have 60 by 6, which is 10 minutes. Time is equal to, yes, work by efficiency, right, which is 10 minutes. That means to complete the remaining work, A takes 10 minutes of time, whereas to complete first part of the work along with B, A takes 20 minutes of time, right? Here the question is total time taken by pipe A, right? So total time taken by pipe A is first 20 minutes and last 10 minutes, right? So if you can mention here, total time taken by A is taken by pipe A. Pipe A is equal to first 20 minutes plus last 10 minutes. Totally it is 30 minutes. Right? Therefore option B is the right answer. Question number 24. If 20 taps together can fill a cistern in 7 seconds, find the time taken to fill the cistern if 8 more taps are attached to the cistern. Here there are 20 taps can fill a cistern in 7 seconds. So here students, if you consider work is filling the cistern, right? So work is nothing but filling the cistern is considered as work. To do this work, how many taps are used? 20 taps are used. Here, the number 20 is considered as capacity or efficiency. In scientific terms, we call it as efficiency. Generally, we call it as capacity. Capacity is number of taps used into time. Total time taken to do the work is 7 seconds. So the work is 7 into 20 is 140 units is work, right? To do the same work, that means to fill the same cistern, if 8 more taps are attached to the cistern. So instead of 20 taps, if 8 more taps means 28 taps are used, right? Then what is the time taken to fill the cistern? Very easy. So instead of capacity as 20, right? If capacity is 20 plus 8. Capacity is equal to 28. Right? So what is the time taken? Right? Therefore, time is equal to time taken to fill the cistern is work by capacity. Right? Here the work is 140 units. Why it is same? Because we are going to fill the same cistern here, right? Therefore, work is same, filling the cistern is same, 140 units. By capacity is here 28, right? Therefore, 140 by 28 is, so 28 into 5, right? 20 into 5 is 100, 8 into 5 is 40. So 5 seconds, right? Therefore, time taken to fill the cistern is 5 seconds. If the capacity is 8 more taps, instead of 20 taps, if it is 28 taps, only 5 seconds are required to fill the cistern. Hence, option B is the right answer. Question number 25. A pipe can fill 2/13th part of a tank in 4 hours. Find the time taken by it to fill the empty tank. So we'll consider a tank and a small portion which is 2/13th part of the tank. So pipe can fill this tank in 4 hours. Right? So here we need to find the time taken by it to fill the empty tank. So to fill the whole tank, what is the total time taken by the pipe? Right? For that, we need the remaining portion of the tank. Right? What is the remaining portion? Remaining part of the tank, and also time taken to fill the remaining part. Right? So for that, we are using the concept of work is equal to capacity or efficiency, right? Both are same, capacity into time, right? Here, to find the remaining part and the respective time, we need the capacity of the pipe. Here, pipe can fill 2/3 portion of the tank in 4 hours, right? What is the capacity of the pipe? Depending upon that, we can easily find the time taken to fill the empty tank, right? So here, capacity of pipe, capacity of the pipe is work by time. What is work here? So filling the tank itself is the work, right? So here work is equal to only 2/13th of work will be done in 4 hours, right? It has been done in 4 hours, right? So we'll consider 2/13th of the total work in 4 minutes of time, right? Therefore, it is 1/26. Capacity of the pipe is 1/26, right? So now What is the remaining part of the tank? Remaining part is, so 1 minus 2 by 13. If 1 is considered as whole tank, so in that the small portion which I am showing, this is 2 by 13th of the tank. So remaining part of the tank is 11 by 13. 11 by 13 is the remaining part, right? So time taken to fill remaining part. Since time is work by capacity, here work is filling the remaining part, right? So 11 by 13 is the filling the remaining part of the, that means work done to fill the remaining part of the tank, divided by capacity of the pipe. So capacity of the pipe is 1 by 26, right? So we have 11 by 13 into 26 by 1. So 13 into 2. So time taken by the pipe to fill the remaining part is 11 into 2 is 22 hours, right? Therefore, to fill the remaining part, pipe take 22 hours of time, right? Here the question is time taken by it to fill the empty tank. So empty tank, to fill this 2 by 13th part, pipe takes 4 hours, and to fill the remaining part, pipe takes 22 hours. So to fill the empty tank, total time is 22 plus 4, which is 26 hours, right? To fill the whole tank, empty tank means whole tank, pipe takes total time of 26 hours, right? Hence, option D is the right answer. Question number 26. Two pipes A and B can fill a tank in 24 minutes and 32 minutes respectively. If both the pipes are opened simultaneously, after how much time B should be closed so that the tank is full in 18 minutes? So students will consider a tank and two pipes are opened, right? Two pipes are opened, A and B pipes, right? So here the total time taken by the pipes is 18 minutes. So that after few minutes, at first both the pipes are opened for T minutes. After T minutes, pipe B is closed. So exactly at this point, B is closed. Pipe B is closed, right? So that in total 18 minutes, the tank is full, right? So after T minutes, only pipe A is opened, right? So in first T minutes, both A and B are opened. Both the pipes are opened. So exactly at this point, at T minute, pipe B is closed. After that, A is opened. Only pipe A is opened, so that the total time taken by both the pipes, right? In this filling process is 18 minutes, right? Here the question is, so after how much time B should be closed? So at T minute, B should be closed. For that, we'll consider like this. At first, A plus B, both the pipes are opened for T minutes. And after that, B is closed, only pipe A is opened for 18 minus T minutes, right? Because the total time is 18 minutes, right? So after how much time? That means we need to find the value of T. Right? So just we are considering simple concept of work here, total work. So what is work here? Filling the tank itself is work, right? Total work is nothing but filling tank, right? Filling tank is considered as total work. According to the concept, it is capacity or efficiency. Both are same, capacity into time, right? So in this particular case, so we have to split the work into two parts, right? In first part, so work has been done by two pipes A and B. So capacity of A plus B into time taken by both the pipes, plus in the second case, B is closed. So it is capacity of A into time taken by A is 18 minus original time. That means first time, right? So we'll consider time taken by A, right? So what is capacity of A and B here? So individually A takes 24 minutes of time to complete some work. Here work is nothing but W, right? So let total work be W. A takes 24 minutes of time to complete W. So capacity of A, or its A's pipe A's 1 minute work is W by 24 plus B's 1 minute work, or its capacity is W by 32. And both the pipes take T minutes of time at first, right, according to our assumption, plus again capacity of A is W by 24, and A takes 18 minus T minutes of time to complete the remaining work, or to fill the remaining part of the tank, right? Here the total work is W. Simplify it. Since LCM is 96, numerator becomes 24 into 4 is 96. It becomes 4W plus 32 into 3 is 96. So it becomes 3W into T plus W by 24 into 18 minus T. So we have 7W by 96 into T plus W by 24 into 18 minus T. So here only the simplification part is left. So here 1 is equal to, we can take out W here. So, and we can cancel, so that 1 remains here in the LHS part. And in the right hand side, we have 7 by 96 plus, so 18 minus T by 24. So 96 into 24 is equal to, so after taking the LCM, here LCM is 96 itself. No need to take the product of that, since 24 is, it can be divisible by 96. 24 into 4 is 96. Otherwise, don't get confused. 96 is the LCM, and the numerator part becomes 7 plus, since 24 into 4 is 96. So 18 into 4 minus T into 4, right? So 72 minus 40, right? So we have 96 is equal to, here it should be 7T, 7 into T, sorry, 7 into T. 76 is equal to 3T plus 72. So 3T is equal to 96 minus 72 is 92, so 24. So T is equal to 24 by 3 is 8. So 8 minutes is T. That means A and B pipes, both the pipes are opened for first 8 minutes. That's what the question is. After how much time B should be closed? Exactly at T minute, right? That 8th minute, B is closed. After 8 minutes, B should be closed, so that the tank is full in 18 minutes, right? Therefore, option B is the right answer. Question number 27. There is a leak in the bottom of a cistern. When the cistern had no leak, it was filled in 2.5 hours. If now takes half an hour longer, if the cistern is full of water, how long would it take in leaking itself empty in case the water leaks out at double the rate after half the cistern becomes empty? So students, we will consider a cistern, right? So it is filled in 2.5 hours. So it is filled in 2.5 hours, right? But it takes half an hour longer. So due to a hole in it, it takes 3 hours, right? So to fill it, right? Therefore, so how long would it take in leaking its empty? First, we'll consider that, right? So in ideal condition, time taken to fill the cistern is 2.5 hours, right? So here, in real condition, time taken to fill the cistern is 3 hours, right? Here work needs to be done on it, right? So filling the cistern itself is work, let it be W, right? In both the cases, filling the cistern, or it may be emptying the cistern when it is full. So same amount of work should be done. Therefore, filling or emptying the cistern, the work has to be done. Therefore, let it be W, right? Therefore, 1 hour work to fill the cistern when total time is 2.5 hours, right? 1 hour work is W by 2.5 hours. 2.5 hours means 5 by 2 hours. So it becomes 2W by 5, right? 2W by 5 becomes 1 hour work. But in the real condition, 1 hour work means 1 hour work. This is 1 hour work of pipe, right? So to fill the cistern, 1 hour work of pipe is 2W by 5 in ideal condition. Whereas 1 hour work in real condition is work by time, W by 3. So this is based on the concept of work, which is 1 hour work into total time. Work is 1 hour work into total time. Therefore, 1 hour work is total work by total time, right? Therefore, so difference between these two works, 1 hour works gives 1 hour work of the whole, right? Here in ideal condition, due to the absence of the whole, 1 hour work, whether it is less or more, it is more, right? Because whole is absent in ideal condition. Due to whole in real condition, 1 hour work is less, right? Therefore, 1 hour work of whole, 1 hour work of hole or leak, both are same, right? 1 hour work of leak is equal to, so difference between these two works, right? So 1 hour work in ideal condition, 2W by 5 minus W by 3, right? Since 15 is the LCM, numerator becomes 5 into 3 is 15, so 2W into 3, 6W minus 5W. So 1 hour work of leak is W by 15, right? W by 15. That means to fill or to empty, right? So here leak can empty the cistern. Therefore, to empty the cistern, right? So to empty what part of the cistern? W by 15. That means 1 by 15th. So which is a small portion. For example, this portion. So let it be 1 by 15th part of the cistern, right? To empty 1 by 15th part, right? Leak takes 1 hour, right? So it is given that, so at a double rate, after half of the cistern becomes empty. So we'll consider time taken to empty half of the cistern, right? So we'll consider time taken to empty half of cistern. That means work needs to be done, right? On that, to empty half of the cistern is equal to, right? So time taken to empty W by 15th or 1 by 15th of the cistern. So it is 1 hour, right? So numerator is 1 hour divided by W by 15. Therefore, that is into time taken to empty W by 2 or 1 by 2 part of the cistern, half of the cistern is equal to, so 15 by 2 it is, right? So which is 7.5, 7.5 hours, right? So time taken to empty first half of the cistern is half an hour. Sorry, 7.5 hour, 7.5 hours, right? So what is the remaining part? Remaining part is again half of the cistern, right? Therefore, time taken to empty remaining half is equal to, and it is given that, so here with double rate, right? So in case water leaks out at double rate, after half of the cistern becomes empty. So here first half of the cistern becomes empty, right, in 7.5 hours. But the second half of the cistern becomes empty with double rate. So double rate means here rate of hole or leak is W by 15. Rate is nothing but 1 hour work, right? It is nothing but W by 15, right? With double rate, what is the time taken by the leak, right? To empty the remaining part. For that, again, we are using the concept of work, which is efficiency into time. Efficiency is nothing but rate. Therefore, so remaining part, so empty the remaining part is nothing but work, right? Work by time gives rate. Sorry, work by rate gives time. We need time here. Work by rate gives time, right? Keeping this in our mind, here work needs to be done is W by 2, right? So emptying the remaining half of the cistern divided by rate of the leak, right? Only leak can empty the cistern. Therefore, W by 15 is the rate, but it is given that with double rate, it becomes 2 into W by 15, right? So with double rate, so it can empty the remaining part of the system. Therefore, what is the time taken by the leak, right? Therefore, it becomes, again, W and W will get cancelled. So we have 15 by 4, right? Therefore, it is equal to 4 into 3 is 12. Then 4 into 7, then 4 into 5, 3.75 hours. So leak takes 3.75 hours to empty the remaining part. So which is 3.75 hours, right? Therefore, so how long would it take to leak or to empty the system? Total time, right? Therefore, total time to empty is equal to, so first half of the cistern can be emptied in 7.5 hours. 7.5 hours, first part, plus 3.7 hours. So time taken to empty remaining part is 3.7 hours. So total it is 11.25 hours. 11.25 means 11 hours. 0.25 means a quarter, right? 1 by 4th of an hour is 15 minutes. 11 hours, 15 minutes, right? So total time taken to empty the cistern is 11 hours, 15 minutes. Option B is the right answer. Question number 28. A cistern is connected with 3 pipes A, B, and C. Pipe A can fill 1/4 part of the cistern in 10 minutes. Pipe B can fill 40% of the cistern in 40 minutes, whereas pipe C can fill 1/3 part of the cistern in 13 minutes. Working alone, which will fill the cistern first? Which pipe will fill the cistern first? Right? For that, so here we'll consider the concept of work is equal to efficiency into time, right? Or capacity. Both are same. Efficiency or capacity into time, right? Here, pipe A can fill 1/4 part of the cistern. So here, if the work to be done is 1/4 part of the work, right? If total work is considered as W, so work is nothing but filling the cistern itself is work, right? Filling the cistern is work. 1/4 of the cistern means 1/4 of the work, right, will be done by pipe A in 10 minutes. So therefore, 1/4 of the work is equal to capacity of pipe A or efficiency of pipe A, into time taken by pipe A to complete 1/4 of the work is 10 minutes, right? Therefore, so we'll consider time as 10 minutes. Right? Whereas pipe B can fill 40% of the cistern. Therefore, 40% of work will be done by pipe B. Therefore, 40% of work is equal to efficiency of B into time taken by B is 40 minutes. Right? Whereas pipe C can fill 1/3 part of the cistern. So 1/3 part of the cistern is 1 by 3 of the total work will be done by pipe C. Therefore, it is equal to efficiency of C into time taken by C to complete 1/3 part of the cistern, right? Or 1/3 part of the work. So we are just using the concept of work here. Here the question is, working alone, which pipe will fill the cistern first? So it depends on capacity of the pipe. If pipe has more capacity, right? If the pipe has more capacity, it will fill the cistern first, right? Therefore, we'll find capacity or efficiency of the pipe in each case, right? Efficiency of A is, so here we'll consider efficiency of pipe A is equal to, so 1/4 of the work divided by 10 minutes, right? Therefore, it becomes W by 40. Work by 40 minutes. That means to complete W amount of work, that means to fill the cistern, pipe A takes totally 40 minutes of time, right? To fill the cistern completely, right? Whereas to fill 1/4 of the cistern, it takes 10 minutes, right? Which is already given. Therefore, to fill complete cistern, here W indicates filling full cistern, right? Filling cistern is considered as a W. To fill that, it takes 40 minutes of time. Whereas pipe B, so it depends on its capacity. So efficiency or capacity of pipe B is 40% of work. So 40% of work is 40 by 100 into W divided by 40 minutes. So 40 and 40 will get cancelled. So W by 100. That means pipe B takes 100 minutes of time. Since efficiency is work by time, pipe B takes 100 minutes of time to fill the cistern. So compared to pipe A, it takes more time. That means it has less efficiency or less capacity. Whereas efficiency of pipe C is equal to, so work divided by 13 into 3, which is 39. So work divided by 39 minutes. So pipe C takes 39 minutes, right? Therefore, so time taken by C is less than time taken by A, which is less than time taken by pipe B. Therefore, efficiency of C is greater than A, right? And efficiency of A is greater than efficiency of B. If the pipe is more efficient, then it will fill the cistern first, right? Therefore, so pipe C, right? Pipe C will fill the cistern first. Pipe C will fill the cistern first, right? Therefore, look at the options. Option C is the right answer. Question number 29. A cistern can be filled by two taps A and B in 4 hours and 6 hours respectively. When full, the tank can be emptied by third tap C in 8 hours. If all the taps be turned on at the same time, the cistern will be full in. So very easy question. So we'll consider a cistern and 3 taps, right? So where 2 taps can fill the cistern, A and B taps can fill the cistern in 2 different time durations, whereas the third tap, let it be C, it can empty the cistern when it is full, right? So if the cistern is full, so it can empty the cistern in 8 hours. Whereas tap A can fill the cistern in 4 hours individually, whereas tap B can fill the cistern in 6 hours individually. Right? Here, filling the cistern, completely filling the cistern is equal to completely emptying the cistern, right? Therefore, so work done to fill or empty the cistern, right? Empty the cistern is same. Cistern is same. Because here same amount of water is going to, we are going to fill the water in the cistern, right? And also same amount of water is taken out of the cistern. Therefore, work done to fill or empty the cistern is same here, right? Keeping this in our mind. So here we need to find time taken by all the 3 taps to fill the cistern, right? If all the taps be turned on at the same time, the cistern will be full in. That's what the question is. To fill the cistern, time taken by all the 3 taps, right? Here, 2 taps are filling the water in the cistern, whereas the third tap is, it is taking out water from the cistern, right? Therefore, it depends on the capacity of the pipes. So filling the cistern depends on capacity of the pipes, right? Therefore, first let us consider capacity or efficiency of the pipes, right? So here tap A can fill the cistern in 4 hours, right? Therefore, efficiency or capacity. So in general terms, we can take it as work done in unit time, right? So particularly it is 1 hour work of tap A, right? Since the time is in terms of hours, so unit time is 1 hour here. So 1 hour work of tap A is total work, which is W, right, by 4 hours. In 1 hour, tap A can fill 1/4 portion of the cistern. 1/4 of total work can be done by tap A in 1 hour, right? Whereas 1 hour work of or efficiency of tap B is total work W. Here W is total work, right? So filling the cistern is considered as total work. W by 6 is 1 hour work of B, because tap B takes totally 6 hours to fill the complete cistern, right? So its 1 hour work is W by 6. Whereas 1 hour work of tap C is total work. Here work is to empty the cistern. Tap C can empty the cistern, right? It takes totally 8 hours to empty the complete cistern, right? So its 1 hour work is W by 8. If all the taps are turned on, right? So if all taps are turned on, their 1 hour work, right? Their unit time work will be, so work of tap A is W by 4 per hour plus W by 6. Both the taps are filling water, whereas third tap can empty the water. Therefore, we have to use the negative sign, W by 8 minus W by 8. Therefore, here 24 is the LCM. So 4 into 6 is the 24, 6 into 4, therefore numerator becomes 4W. 8 into 3 is 24. Hence, we have 7W by 24. So if you consider numerator as the whole work, total work, denominator becomes 24 by 7, which is nothing but total work by total time. Total time is nothing but 1 hour work. That is efficiency of all the 3 types, right? Their 1 hour work is total work by total time. That means all the 3 pipes A, B, C take 24 by 7, 7 hours of time, right? Therefore, time taken by ABC pipes, right, to fill the cistern completely is 24 by 7 hours, right? So look at the options. So options are in terms of 3 hours and so minutes. So we'll simplify this time. So here 24 by 7. Let us express this hours in terms of minutes. So into 60 is in terms of minutes. So we have 16 for 24. 12 plus 2, 14 by 7 minutes. Still you can simplify. So here 7 into 2, 7 into 5 is 35. 7 into 7. So 205.7, which is approximately equal to 206 minutes. So 206 minutes is equal to 206 by 60 hour, right? So 60 into 3 is 180 and 26 is remainder. So 3 hours 26 minutes is the total time taken by taps A, B and C to fill the cistern completely. 3 hours 26 minutes. Hence option C is the right answer. Right? Here only thing is you should know which tap can empty the cistern. For that, the respective capacity. So the respective capacity is W by 8. This value should be subtracted, right, from the capacities of other two taps. Therefore, we get the answer as 3 hours 26 minutes. Question number 30. A pipe takes 12 hours to fill a tank, but due to a leakage at the bottom of the tank, it takes 14 hours to fill the tank. When the tank is full, in what time will the leakage empty it? So here, we'll consider a tank and a pipe. So it can fill the tank in 12 hours. In ideal case, this pipe can fill the tank in 12 hours. But in reality, it takes 14 hours. So due to leakage, right, at the bottom, so it takes 14 hours. So here, the question is, when the tank is full, in case the tank is full, in what time this leakage can empty the tank, right? Time taken by this leakage, this leak, right, to empty the tank will be. So it depends on capacity of the leak, right? Capacity of the leakage or the hole, right? So how to find capacity of the hole? For that, we'll consider the ideal case and real case in which the tank can be filled, right? So in ideal case, time taken by the pipe is 12 hours, whereas in the real case, time taken by the pipe is 14 hours. If you consider the total work to fill the tank as W in both the cases, so work will be same because same amount of water will be filled in the tank. Therefore, work will be same. Therefore, capacity of pipe in each case, so capacity, or you can call it as efficiency of pipe A is equal to work by W by time taken. Because work is always efficiency or capacity into time. Here capacity is nothing but work per unit time, right? So it's 1 hour work. The pipe's 1 hour work is called its capacity, right? So capacity of the pipe in ideal case is W by 12. That means pipe A can fill 1 by 12th portion of the tank in 1 hour. Right, I'll repeat. Pipe A can fill 1 by 12th, small portion of the tank, right? Maybe this small portion, right? Small portion of the tank in 1 hour, right? But in real case, capacity of pipe A is total work by time, W by 14. So it can fill only 1 by 14th portion, still smaller portion, right? 1 by 14th portion of the tank in 1 hour, right? Therefore, what is the difference between the capacity of the pipe in two different cases? In ideal case and real case. So it is nothing but the capacity of the hole or capacity of the leakage, right? Therefore, capacity of the leakage. Why is the difference here? Because of the capacity of the leakage at the bottom, water is flowing out of the tank, right? Therefore, in the real case, it takes more time, 14 hours of time to fill the tank, right? Therefore, capacity of the leakage is capacity of pipe A in ideal case minus capacity of pipe A in real case. This difference gives capacity of the leakage, right? Therefore, here the LCM is 84, right? So 12 into 7 is, yes, 12 into 7 is 84. So numerator becomes 7W minus 14 into 6, right? 6 is 84. Therefore, we get W by 84 is capacity of leakage, where W is total work. That means with respect to leakage, work to be done to empty the tank is called total work, right? Not only to fill, work to be done to empty the full tank is also called the total work, right? So total work by total time taken by the leak. Therefore, total time taken by the hole to empty the tank is equal to 84 hours. Here time is in terms of hours, right? Therefore, time taken by leakage. Taken by leakage to empty the tank is 84 hours. Right? Look at the options. So in option A, we should make a small change. Instead of 42, it should be 84 hours. Right? So here is a small error. 84 hours. Option A is the right answer. Question 31. A tank is connected to two pipes. One of these pipes can fill the tank in 15 minutes while the other can empty it in 10 minutes. If the tank is initially 3/5 full and both pipes are simultaneously opened, how much time it will take to fill or empty the tank? So we'll consider a tank and an inlet pipe, right? So a pipe can fill the tank in 15 minutes, right? So we'll consider pipe A, which takes 15 minutes of time to fill the complete tank. Whereas we have an outlet pipe B, it takes only 10 minutes time to empty the tank. If it is full, the pipe B takes only 10 minutes time to empty it. So it is given that initially the tank is 3/5 full. So 3/5 portion of the tank is full initially. Right? This is 3/5 portion of the tank. Right? So here the question is, if both the pipes are simultaneously opened, so if it is 3/5 full, if the tank is 3/5 full and both the pipes are opened simultaneously, how much time it will take to fill or empty the tank? So to empty the tank or to fill the tank, what is the time taken by both the pipes, right? So here students, time taken by pipe A is 15 minutes, right? So whereas time taken by pipe B is 10 minutes. That means capacity of pipe B is more, right? Capacity of pipe B is greater than A. That means B can empty the tank very easily, right? So compared to pipe A. That means, so the process of emptying the tank is easier compared to filling the tank. Do you agree? So that means if 3/5 is full, when both the pipes are opened at the same time, right, simultaneously both the pipes are opened, emptying the tank will be easy, right? So emptying the tank means 3/5 portion of the tank should be emptied, right? So this emptying the tank depends on capacity of both the pipes, right? Because both the pipes are opened, inlet and outlet, water is going inside the tank and also going out of the tank simultaneously, right? Therefore, so what is the time taken by both the pipes to empty the tank? That's what the question is. It depends on capacity of both the pipes, right? So capacity of pipe A, capacity of pipe A is, according to the concept of work is equal to efficiency into time. Here efficiency is nothing but capacity of the pipe, right? In unit time, here time is in terms of minutes. In 1 minute, what amount of work can be done by the pipe is called its capacity or efficiency. So capacity of pipe A is total work to be done divided by time, right? In order to fill the complete tank, pipe A takes 15 minutes. So if work is considered as W, so W is nothing but, work is nothing but filling the tank itself is work, right? So work by total time. Work by total time is efficiency or capacity of pipe A, right? That means, so 1 by 15th portion of the tank will be filled in 1 minute. That is nothing but capacity of pipe A. 1 minute work is considered as its capacity. Whereas capacity of pipe B, capacity of pipe B, total work by time taken by outlet pipe is only 10 minutes. So its capacity is W by 10. So 1 by 10th portion, that means, so compared to the previous portion, 1 by 15th portion, 1 by 10th portion is greater, right? So it can empty the tank. So in the rate of 1 by 10, that means 1 by 10th portion of the tank can be emptied, right, in 1 minute, right? Therefore, their capacities are like this. If the tank is initially 3/5 full, right? What is the time taken by the pipes to empty the tank? Here, work to be done is, right? Work to be done is, we have to empty 3/5 portion of the tank, right? Because it is already full, 3/5 portion is already full. We have to empty the tank, right? That is work done, right? Therefore, 3/5 of total work done is considered as 3/5 of tank to be emptied, right? 3/5 of work is equal to efficiency or capacities of both the pipes. So, capacity of B is greater compared to A, right? Therefore, W by 10 minus W by 15. Why we use negative sign? Because one of the pipes is inlet, another one is outlet, right? Therefore, the difference in their capacity is to be considered into time. We need to find the time, how much time it will take to empty the tank, right? Simplify it. Since 30 is the LCM, numerators become 3W minus 2W into time taken by the pipes, right? So simplify it. So W by 30 into T is equal to 3 by 5 into W. So W and W will get cancelled. T is equal to 3 into 30 by 5. So 5 into 6 is 30. So 18 minutes. So both the pipes take 18 minutes of time to empty the tank, right? So simultaneously, so A is inlet pipe. That means A is sending water inside the tank, whereas pipe B is sending out water outside the tank, right? So in this case, both the pipes take 18 minutes of time to empty the tank. Hence, option A is the right answer. Question number 32. Three pipes A, B, and C are attached to a cistern. The pipe B alone can fill the cistern in 6 hours. B and C together can fill it in 4 hours. And A, B, and C together can fill it in 2 integer 2 by 3 hours. Find the taken by A and B together to fill the cistern. So here we'll consider a cistern and 3 pipes A, B, and C, right? A, B, and C. To fill the cistern, B alone can take 6 hours of time. So we'll consider pipe B. It takes 6 hours of time to fill the cistern. And B and C together, here is pipe C. Together, B and C take 4 hours of time, right? Whereas A, B, C, 3 pipes, all the 3 pipes together, they take 2 integer 2 by 3 hours. So here we need to find time taken by A and B together. So whenever the word is given together, that means when 2 pipes are opened simultaneously, we need to consider their capacity or their 1 hour work, right? 1 hour work or efficiency, right? Efficiency, because capacity or efficiency or their 1 hour work is expressed in terms of work divided by total time, right? So here work is equal to 1 hour work, 1 hour work into total time, right? So if you consider their 1 hour work, 1 hour work of each pipe, so this is nothing but work divided by total time. So easily we can find time taken by that respective pipe or more than one pipes together to fill the cistern, right? Therefore, let us consider the capacities or 1 hour works of each pipe, right? It is given that B alone can fill the cistern in 6 hours, right? Therefore, pipe B is 1 hour work. B is 1 hour work. If W is taken as the total work, 1 hour work is total work by total time. So B takes 6 hours of time. So W by 6 is B is 1 hour work. That means pipe B can do 1 by 6th of total work in 1 hour, right? 1 by 6th of total work in 1 hour. Whereas B plus C together can fill the cistern in 4 hours. So we'll consider B plus C is 1 hour work. B and C is 1 hour work is equal to total work by 4. So B and C together can do 1 by 4th of the total work, right? 1 by 4th of total work in 1 hour. And A, B, C together can fill the cistern in these many hours, right? Therefore, A plus B plus C's, all the 3 pipes, when 3 pipes are opened, 1 hour work of these 3 pipes is equal to total work divided by time taken by them. 2 integer 2 by 3 is their capacity or 1 hour work. Here we need to find time taken by A and B together. For that, we need to consider A plus B is 1 hour work. B is 1 hour work. Right? So how to find A plus B is 1 hour work? B is 1 hour work is directly given. Right? So we'll consider it as equation 1. So what is A's 1 hour work? So A's 1 hour work is nothing but A plus B plus C is 1 hour work minus B plus C is 1 hour work. Right? So therefore, pipe A is 1 hour work is equal to A plus B plus C is 1 hour work, which is W by 2 integer 2 by 3 minus W by B is 1 hour work is W by 4. Right? Therefore, W by 2 integer 2 by 3 is 8 by 3. So this 3 goes to numerator minus W by 4. So 3W minus 2W by 8 is the answer. So A's 1 hour work is W by 8. Pipe A's 1 hour work is W by 8. That means pipe A can fill 1 by 8th portion of the total work. Right? 1 by 8th portion of the cistern can be filled by pipe A in 1 hour. Right? Therefore, A plus B's 1 hour work will be, so consider this. So A's 1 hour work is W by 8 plus B's 1 hour work is W by 6. Right? So here 24 is the LCM. So 3W plus 4W. Therefore, totally it is 7W by 24. So 1 hour work is nothing but total work, which is W by 24 by 7. So this 7 in the numerator will go to denominator, right? Here, denominator of the denominator. So here, total time taken by A plus B. That's what the question is. Time taken by A and B together to fill the cistern. So, time taken by A and B together is equal to 24 by 7, right? Because we have expressed A plus B is 1 hour work, right? In terms of work and time here. Therefore, 24 by 7, the unit of the time is hours here. Hours. 24 by 7 hours means 7 into 3 is 21. So 3 is the remainder. 3 integer 3 by 7 hours. Right? 3 integer 3 by 7 hours is the answer. Option A is the right answer. Students, if you want to practice such questions on pipes and cisterns, please visit our website at www.examsnet.com. You can also download our app. The link is given in the description box. Question 33. A cistern is connected with 3 pipes A, B and C, where A and C are inlet pipes and B is an outlet pipe. Pipes A, B and C alone can fill the cistern in 15, 20 and 10 minutes respectively. Pipes A and B were opened for 10 minutes. Then pipe B was closed and pipe C was connected along with pipe A to fill the cistern. Find the time taken by pipe A and C to fill the remaining part of the cistern. So students, a cistern has 3 pipes, 2 inlet pipes, right? A and C are inlet pipes, right? Whereas B is an outlet pipe. B is an outlet pipe. And A alone can take 10 minutes of time to fill the complete cistern, whereas pipe C takes, A takes 15 minutes of time, sorry. not 10, 15 minutes. And pipe C takes 10 minutes of time to fill the cistern separately, right? Whereas pipe B takes 20 minutes of time. Here, pipe B is an outlet pipe. It takes 20 minutes of time to empty the cistern, not to fill the cistern, right? Here, amount of water to be filled to fill the complete cistern is same as amount of water to be emptied out of the cistern. Therefore, time taken by B is same, whether it is to fill the cistern or empty the cistern. So time will be same, since amount of water to be filled or to be emptied is same, right? So here the question is, so time taken by pipe A and C to fill the remaining part of the cistern. So to find the remaining part of the cistern, what is the part of the cistern which is already filled? First we need to find. It is given that pipe A and B, so A plus B pipes were opened for 10 minutes. For 10 minutes, pipe A and B were opened. And after 10 minutes, pipe B was closed. And pipe C was connected along with pipe A. So after 10 minutes, A and C pipes were opened, right? So to fill the cistern, right? So what is the time taken by pipes A and C to fill the remaining part of the cistern? For your better understanding, I'm showing like this, right? Therefore, so what part of the cistern is filled already in 10 minutes, right? So, therefore, part of the cistern filled to be calculated first, right? So, part of the cistern filled in 1 minute, right? Therefore, in 10 minutes, what part of the cistern is filled? That we need to find, right? So, in 10 minutes, first 10 minutes, what part of the cistern is filled? Next comes, what is the remaining part of the cistern? Remaining part of the cistern to be filled, right? For example, if you consider, so first this much part of the cistern is filled. This much part of the cistern is filled, and which I am showing now, this is the remaining part of the cistern to be filled. This remaining part will be filled by pipes A and C, right? So in what time these remaining part of the cistern will be filled? That is what the question is, right? So for that, we'll consider capacity or efficiencies of each pipe, right? So for that, so you have to find the remaining part and time taken to fill remaining part. This is the last answer, right? These are the 3 steps in this question. So we'll consider the first step, right? So in first step, we need to find part of the cistern filled in 10 minutes. For that, we'll consider 1 minute work of pipe A. 1 minute work of pipe A. Why do we need 1 minute work? Because in first 10 minutes, A and B pipes are opened, right? 1 minute work of pipe A is, so according to the question, pipe A can fill the cistern in 15 minutes, right? It is given already. So pipe A's 1 minute work is total work W by 15. So 1 by 15th part of the cistern will be filled in 1 minute by pipe A. Whereas 1 minute work of 1 minute work of pipe B. Pipe B is total work. Work is nothing but filling the cistern itself is the work. W by pipe B takes 20 minutes. But it cannot fill the cistern. It can empty the cistern, right? Therefore, so what part of the cistern is filled here? If A and B were opened, that we need to find, right? Therefore, portion of or part of the cistern filled in 10 minutes. 10 minutes is equal to, in 1 minute, in 1 minute, pipe A and B, when both the pipes were opened, so we'll consider W by 15, right? Since pipe B is an outlet pipe, we have to show the negative sign, W by 15 minus W by 20. 1 minute work of pipe A minus 1 minute work of pipe B, because pipe B is throwing water out of the cistern. So with negative sign we have to show. This is their 1 minute work, right, into 10 minutes, right? So 1 minute work into 10 minutes work means a 10-minute work of pipe A and B, that is part of the cistern filled in 10 minutes. Simplify it, since 60 is the LCM. So numerator becomes 4W minus 3W, right, into 10. This gives W by 60. So into 10 gives W by 6. So 1 by 6 part, 1 by 6 part of the cistern is filled in 10 minutes. So this is 1 by 6th part, right? 1 by 6 part. What is the remaining part to be filled here? Remaining part to be filled. To be filled is equal to, if 1 is the whole part, or if W is the total amount of work to be done to fill, minus W by 6 is the remaining part, right? Therefore, 5W by 6 amount of work has to be done, right? 5W by 6 is, or 5 by 6 part is the remaining part, right? This will be filled by pipes A and C, right? Therefore, 5W by 6 is the remaining part, is equal to capacities of pipes, capacities of A and C into time taken by A and C. We need time taken by A and C. Here, capacity of pipe A is already given W by 15, which is 1 minute work of pipe A, and capacity of pipe C is W by 10. So, W by 15 plus W by 10 into time is equal to the remaining work or remaining part to be filled. Simplify it. Simplify it. Since LCM is 30, numerator becomes 5W into time is equal to 5W by 6. Since we can cancel 5W and 5W, time taken by pipes A and C becomes 30 by 6, which is equal to 5 minutes. So, pipes A and C, these two pipes take 5 minutes. Is the, what is the unit of time here? Yes, in terms of hours. So pipes A and C take 5 minutes of time to fill the remaining part of the cistern. Hence option A is the right answer. Question 34. A swimming pool has 3 drain pipes. The first 2 pipes A and B operating together can empty the pool in half the time that third pipe C alone takes to empty it. Together they can empty the pool in 3 hours 36 minutes. Find the time taken by pipe A alone to empty the pool. So here students, the data is inadequate to solve the question, right? Time taken by pipe A cannot be calculated by the given data, right? Option E is the right answer, because if you consider time taken by, so it is given that A and B pipes, right? A and B pipes take half of the time taken by pipe C. So if you consider time taken by pipe C as T minutes or T hours, for example, so time taken by A and B together becomes T by 2 hours, right? T by 2 hours. So it is given that pipe C alone takes some time to empty the tank. So that means work done becomes, so capacity of pipe C into time taken by it, right? So we'll consider capacity or efficiency of work is equal to efficiency or capacity into time, right? So capacity of pipe C, it becomes work done by time. Work to be done here is emptying, right? So to empty the tank. or empty the pool, right? To empty the pool is work to be done here. So work by time gives its capacity, right? So pipe C's capacity is W by T, right? So here capacity of pipes A and B, two pipes A and B operating together can empty the pool in half the time that pipe C takes. So we'll consider capacity of A plus B. So A plus B, in order to do W amount of work, A plus B take T by 2. Half of the time taken by C is T by 2, right? And together they take. So how much time together these three pipes can empty the pool in 3 hours 36 minutes. So total capacity becomes total capacity. So A plus B plus C. Capacity becomes total work done, which is W, by total time taken by them is 3 hours 36 minutes. Right? Therefore, W by 3 hours 36 minutes means 180 plus 36, which is 216 minutes, is total time taken by 3 pipes. So we need time taken by A alone, pipe A alone. Right? So here, total capacity, we can split their capacity as capacity of A plus B, right? Capacity of A plus B plus capacity of C, right? Capacity of A plus B is W by T by 2. W by T by 2 plus capacity of C is W by T is equal to W by 216. So this LHS part becomes, since T is the LCM, so 2W plus W is 3W by T becomes W by 216. Right? We can cancel W and W. So value of T becomes 216 into 3, which is 18, 4, yeah. 648 minutes becomes value of T, time taken by pipe C. Right? So here time taken by pipe A alone is asked. So we can calculate time taken by A and B, right? Since their total capacity is given, capacity of A plus B is given. So time taken by A plus B can be calculated, right? Since T is 648, T by 2 becomes 648 by 2, which is 324, right? 324 is time taken by A plus B, whereas T is time taken by C. We cannot calculate time taken by pipe A alone, right? Since time taken by B is not given, if time taken by B is given, so we can easily calculate time taken by A, right? So you can mention, since time taken by pipe B is not given, pipe B is not given, so time taken by pipe A cannot be calculated. The reason is this. If pipe B takes so and so time, right? So it may be T by 3 or 2T, so whatever it is, right? So if pipe B time is given, the time taken by A will be, so 324 minutes minus time taken by B, right? Easily we could have calculated. So here, because of inadequate information, so the answer cannot be calculated. Hence option E would be the answer. Data inadequate is the answer. Option E. Question number 35. Three taps A, B, and C can fill a tank in 12, 15, and 20 hours respectively. If A is opened all the time and B and C are opened for 1 hour each alternatively, the tank will be full in. So very simple question. Here A, B, C can fill the tank so separately in 12, 15, and 20 hours, right? So we'll consider their times later. So here A is opened all the time, right? So here, so for first hour, right? So A and B taps are opened, right? Here B and C are open for 1 hour each alternatively, right? In the next 1 hour, along with A, tap C is opened, right? again tap B will be opened along with A, right, in the third hour. Whereas in the fourth hour, one more hour. So along with A, tap C will be opened like that. So what is the total time taken to fill the tank, right? So the tank will be full in, right? In how many hours tank can be filled. Here students, 1 hour work of A and B, will consider 1 hour work, right? If you consider total work as W, right? Here time taken by A is 12 hours, right? To completely fill the tank, right? Therefore, 1 hour work of A is, will consider 1 hour work of A plus B, right? Therefore, in 1 hour, along with A, B can do the work, right? Tap B can do, or B can fill the tank. Therefore, 1 hour work of A plus B is W by 12 plus W by 15. So, work by time is called 1 hour work, right? So, which is equal to, since 60 is the LCM, numerator becomes 12 into 5, 15, so 9W by 60, right? Whereas 1 hour work of A plus C, A is 1 hour work is W by 12, plus C is 1 hour work is W by 20, right? So here it becomes, their 1 hour work becomes 12 into 5 and 20 into 3, so 8W by 60, right? So A plus B and A plus C's. So together it becomes 2 hour work, right? So 2 hour work becomes, 2 hour work becomes, so 9W by 60. So first hour work. Second hour work is 8W by 60. Together it becomes 17W by 60, right? So in 2 hours, amount of work has been done is 17W by 60. Right? So to complete the work, right? So the total work to be done here is 60W by 60. Total work should be W, right? So it is nothing but 60W by 60. So here in another 2 hours, right? So another 2 hours, again 17W by 60 amount of work will be done by A plus B and A plus C in another 2 hours, right? And in the next 2 hours, alternatively B and C are joining with A. So A plus B and A plus C can do 17W by 60 amount of work, right? So totally it becomes 17W plus 17W plus 17W. It becomes 51W, right? Right? Therefore, remaining work becomes, here remaining work is equal to total work W, right? This is total work minus 17W plus 17W, 17W by 60, so which is 51W by 60, right? So which is equal to, since 60 is the LCM, so numerator becomes 60 minus 51W, which is 9W, right? Therefore, in 2 plus 2 plus 2, in 6 hours, 51W by 60 amount of work has been done by A plus B and A plus C, right? Alternatively. Then in the next 1 hour, right? So here A plus B can do A plus, right? In the next 1 hour, so B has to join with A, right? Right? So here A plus B can do 9W by 60, right? So 9W by 60 work will be done by A plus B in 1 hour. Right? So totally they take, so 2 plus 2 plus 2 plus 1, right? So which is 7 hours, right? Totally they take 7 hours of time, right? So in first 2 hours, 17W by 60. In the next 2 hours, 17W by 60. In the next 2 hours, again 17 by W by 60. And in the next 1 hour, So it is 9W by 60. Totally it becomes 60W by 60, which is total work, right? Therefore, totally they take 7 hours of time. Option D is the answer. To complete the work or to fill the tank, A, B, C, taps A, B, C take 7 hours of time. Option D is the right answer. Question number 36. A cistern can be filled by 3 pipes together in 12 minutes. The first 2 pipes can fill it in 15 minutes. Working alone, find the time taken by the third pipe to fill the cistern. So students will consider 3 pipes as A, B and C, right? Here A and B together take 15 minutes. First 2 pipes can fill it in 15 minutes. So in 15 minutes, 2 pipes can fill the cistern, right? So here we need to find time taken by C alone. Let it be TC. What is the value of TC? So what is the time taken by C alone to fill the cistern, right? So filling the cistern, let the work be W. Let filling the cistern is equal to W, or 1 unit can also be taken, right? So here, so to fill the cistern, 3 pipes together take 12 minutes of time, right? Therefore, total work, which is nothing but filling the cistern, right? So filling cistern, right, is equal to, here total work can be expressed in terms of 1 hour work or 1 unit work or efficiency, right? Efficiency into time. Efficiency into time, or 1 minute work into time, right? Here, so total work has been done by 3 pipes in 12 minutes, right? Therefore, 3 pipes A plus B plus C in 12 minutes, right? In 12 minutes, where A plus B is nothing but efficiency of A and B, right? So here efficiency of A plus B, right? Plus C, we'll take it separately. So into 12 minutes, right? So what is efficiency of A plus B? It is given that A plus B, they take 15 minutes of time to fill the cistern, right? Together they take. Therefore, we are taking efficiency as A plus B, so which is nothing but W by 15 minutes plus, so time taken by C is W by TC. Let it be TC, right? So their efficiency into time gives the total work, right? Here we need the value of TC, right? So we can take out W, becomes 1 by 15 plus 1 by TC into 12. So that we can cancel W and W. Therefore, take this 12 to the LHS part, it becomes 1 by 12, right? Minus 1 by 15 is equal to 1 by TC. Since 60 is the LCM, 12 into 5 is 60, 15 into 4 is 1 by TC. Therefore, 1 by 60 is 1 by TC. Therefore, TC, time taken by C to fill the cistern, is 60 seconds. Since time is in terms, 60 minutes. Time is in terms of minutes. So TC is 60 minutes or 1 hour, right? Therefore, so pipe C alone takes 1 hour of time to fill the cistern, whereas pipes A and B together, they take 15 minutes to fill the cistern, right? Therefore, option B is the right answer. Question 37. Pipe A and B can fill tank in 43 and 41 minutes respectively. Both the pipes are opened simultaneously, but pipe B is closed after 19 minutes. The remaining portion of the tank is filled by pipe A alone. Find the time taken by pipe A in order to fill the remaining portion of the tank after pipe B was closed. So students, for first 19 minutes, both pipe A and B were opened, right? After 19 minutes, pipe B is closed, right? So pipe B is closed means only pipe A is opened after 19 minutes, right? Here we need to find time taken by pipe A, right? In order to fill the remaining portion of the tank. So for that, let us consider portion of the tank filled in 19 minutes, right? So we know that work, here work is nothing but filling the tank, right? Is equal to, so unit time work, which is 1 minute work into total time, into total time. We'll consider 1 minute work of A plus B, right? For that, we need 1 minute work of A and B separately, right? So 1 minute work of A is, A can do a work in 43 minutes. A can fill the tank in 43 minutes. Therefore, A's 1 minute work is W by 43. And 1 minute work of B. 1 minute work of B is W by 41. Right? So A and B, they work for 19 minutes. Therefore, 19 minute work of A and B. Work of A and B. So it is 19 into A's 1 minute work, which is W by 43, plus B's 1 minute work, W by 41. This is 19 minute work, right? So we can simplify it, right? So here 43 into 41 is the LCM, and the numerator becomes 41W plus 43W, which is 84W into 19, right? Into 19 is their 1 minute work, right? So remaining work has been done by A alone. What is the remaining work? So we'll consider remaining work. Remaining work is equal to total work, which is W minus 19 minute work. 19 minute work is 19 into 84W divided by 43 into 41, right? Since 43 into 41 will take the product of 43 and 41, so 1763 into W. Since 43 into 41 is the LCM, and the numerator becomes 1763, which is product of 43 and 41 into W minus 19 into 84. So you will get 1596 W, right? So you will get 1763 minus 1596. So 167 W by 43 into 41 as the remaining work. Remaining. So remaining work has been done by A in how many minutes? Since work is 1 minute work into total time, therefore remaining work, so which is 167 W by 43 into 41. This is the remaining work is equal to efficiency of A or 1 minute work of A. It is 1 minute work into total time. So 1 minute work of A, which is W by 43. W by 43 into time taken by A. Time taken by A to complete the remaining one, right? Since we can cancel 43 and 43, W and W. Therefore, time taken by A is 167 by 41. So, 41 into 4 is 164. 3 is the remainder. So, 4 integer 3 by 41 minutes is time taken by A to complete the remaining portion, not the complete work. It is 4 integer 3 by 41 minutes. Hence, option C is the right answer. Question number 38. Two pipes A and B can fill tank in 15 minutes and 20 minutes respectively. Both the pipes are open together, but after 4 minutes, pipe A is turned off. The time required to fill the tank. So exactly like the previous question, here also, very easy question. Here, A and B, both the pipes were opened for 4 minutes, right? And after 4 minutes, pipe A is turned off. That means pipe B is opened, right? So time required to fill the tank. So the total time we need to find. Total time. So for that, we need a time taken by B, right? What is the time taken by B to fill the remaining portion? So first let us consider the portion filled in 4 minutes, right? So portion filled in 4 minutes. For that we need 1 minute work of A and B, right? So 1 minute work of pipe A is, if total work as W, so we'll consider filling the tank, right? Filling the tank, the work is considered as W. 1 minute of work, 1 minute work of A is W by 15, right? Whereas 1 minute work of B. So 1 minute work of B is W by 20. So A and B, they worked for 4 minutes, right? So pipe A and B opened for 4 minutes. Therefore, 4 minute work of A and B. A and B is equal to 4 into A is 1 minute work, right? B is 1 minute work. So 4 into, since LCM is 60, right? 60 is the LCM. 15 into 4 is 60. Therefore, numerator becomes 4W. And 20 into 3 is 60. So we have 4 is 60 by 4. 4 into 15 is 60. So here denominator becomes 15. Numerator becomes 7W. So 4 minute work of A and B. So A plus B's 4 minute work is 7W by 15, right? So after 4 minutes, pipe A was closed, right? So what is the remaining work? Remaining work is equal to, so the total work is W minus work done in 4 minutes. So 7W by 15. 7W by 15. So it becomes 15W minus 7, which is 8W by 15 is the remaining work. So remaining work has been done by B. Therefore, 8W by 15 work is equal to 1 minute work into time. 1 minute work of B is W by 20, right? So W by 20 into time taken by B. Time taken by B. Therefore, B takes, so time taken by B is equal to, so 8W by 15 divided by W by 20. So W and W will get cancelled. We have 8 into 20. 20 goes to numerator by 15, right? So here 5 into 3, 5 into 4, 32 by 3. Time taken by B is, time B is 32 by 3 minutes, right? So what is the total time taken? So first 4 minutes and B takes 32 by 3 minutes, right? So total time taken is, total time taken to fill the tank is first 4 minutes plus 32 by 3. Since 3 is the LCM, 12 plus 32 by 3, which is 44, right? 44 by 3 minutes, right? Still you can simplify, right? So it is equal to 44 by 3 is 3 into 1, 3 into 4 is 12, right? So 14 integer 2 by 3 minutes, right? 14 integer 2 by 3 or 14 minutes. 2 by 3 means, so whole 3 part is considered as 60 seconds, makes 1 minute. In that 2 part is taken, that is 40 seconds are taken, right? So that means 2 by 3 means 40 seconds. So 14 minutes, 40 seconds. 14 minutes, 40 seconds is the total time taken to fill the tank, right? 14 minutes, 40 seconds. Option A is the right answer. Question number 39. Two pipes A and B can fill a cistern in 8 minutes and 12 minutes respectively. Starting with A, if both the pipes are opened alternatively for 1 minute each, in what time will they finish the cistern? So, students, starting with A. So, first pipe A, right, fills some portion of the cistern, right, in 1 hour, not in 1 hour, in 1 minute, right? Unit time is 1 minute here. So, after that, B fills some portion of cistern in another 1 minute, right? And in the next minute, again, A fills some portion of cistern, right? Like that, it continues, right? What is the total time taken by pipe A and B to fill the cistern? That we need to find, right? Total time taken by A and B. And it is given that A takes 8 minutes of time to fill the cistern, whereas B takes 12 minutes of time to fill the cistern individually, right? So based on these two times, we have to find the capacity of A or 1 minute work of A, right? So A is 1 minute work. If total work is taken as W, or total work to fill the cistern is taken as W. So A's 1 minute work is W by A takes 8 minutes of time, right? Whereas B's 1 minute work is W by 12. That means in 2 minutes, so 2 minutes work of 2 minutes work is equal to, so in 1 minute A does the work and in next minute B does the work. 2 minutes work means, so since 24 is the LCM, so numerator becomes 8 into 3, 12. So it becomes 5W by 24. Right? 2 minutes work becomes 5W by 24. Here the total work is W. Right? Total work is W. Therefore, in another 2 minutes, right? Another 2 minutes, 5W by 24 amount of work will be done by A and B alternatively, right? And in another 2 minutes, right? In another 2 minutes, A and B do the amount of work which is 5W by 24, right? So in another 2 minutes. So totally we need 24W by 24, right? So total work is W, which is nothing but, total work is W is nothing but 24W by 24, right? So you have to equate the numerator part to 24, right? So therefore, so in another 2 minutes, A and B do the work of 5W by 24, right? So totally it becomes 20W by 24, right? In 2 plus 2 plus 2 plus 2, so 8 minutes work. 8 minutes work is equal to 5W, 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 5W. It is 20W by 24, right? What is the remaining work? So remaining work is equal to, so total work minus already done work in 8 minutes, right? 20W by 24. Remaining work is 24 minus 20 is 4W by 24, right? Which is nothing but W by 24 by 4 is W by 6. So remaining work is equal to W by 6. Since W by 6, so after B, so A starts working. A starts filling the cistern, right? But capacity of A is only W by 8, which is lesser than the remaining work, right? Right? So therefore, so in W by, out of W by 6, W by 8 amount of work will be done by A, right? A plus B does some work. What is the work done by B, right? Therefore, so in 1 hour, right? In 1 hour, A does W by 8 amount of work, right? In 1 hour. And in the very next hour, in another hour, B does what amount of work, right? That we need to find, right? Therefore, B's work remaining, or B's work at last is W by 6 minus W by 8. Since 24 is the LCM. So 4W minus 3W. So W by 24 is the remaining work, right? So remaining work will be done by B, right? So we'll consider the remaining work. Remaining work will be done by B. So it depends on B's capacity into time. So B's 1 hour work, 1 minute work into time, right? So what is remaining work? W by 24 is equal to, what is 1 minute work of B? It is W by 12, right? So remaining work is W by 12 into time taken by B, TB, right? Therefore, time taken by B is W and W will get cancelled. It is 12 by 24, right? So B takes half a minute, right? So to complete the remaining portion, B takes half a minute. It is not hour, half a minute. So the total time is, 8 minute plus 1 minute work of A and half a minute, right? So total time is 9.5. Total time to fill the cistern is 8 plus 1 plus half. So which is 9.5 minutes, right? So totally they take 9.5. Option C is the right answer. Question number 40. 3 pipes A, B and C can fill a tank in 6 hours. After working it together for 2 hours, C is closed and A and B can fill the remaining part in 7 hours. How much time will C take alone to fill the tank? So students, it is given that A, B, C together can fill the tank in 6 hours. A plus B plus C take 6 hours of time, right, to fill. Right? So they A, B and C pipes open for only 2 hours, right? So A plus B plus C, 3 pipes were opened for only 2 hours. After that, tap C is closed. That means after that, only A and B pipes were opened, right? So A and B pipes can fill the remaining part in 7 hours. In 7 hours, A and B pipes can fill the remaining part of the cistern or tank in 7 hours. Here the question is, how much time will C take alone to fill the tank? So time taken by C, right? So time taken by C, right? What is the time taken by C? So to find that, we'll consider 1 hour work of C, right? So what is 1 hour work of C? So 1 hour work can be expressed in terms of total work by total time taken, right? So here total work by total time taken, right? Therefore, we can easily find total time taken by C alone to complete the total work, right? So we'll find 1 hour work of C. For that, we need 1 hour work of A plus B plus C and 1 hour work of A plus B. That gives, so A plus B plus B, A plus B plus C minus A plus B. So 1 hour work of these two gives 1 hour work of C, right? We'll consider it one by one, right? So here A, B, C together can fill the tank in 6 hours, right? So 1 hour work of A plus B plus C together is equal to total work. If total work is taken as W, so W by 6 is their 1 hour work, right? Now we will consider 1 hour work of A plus B, right? So for that, what is the remaining work that we need to find? For that, what is 2 hour work? So we'll consider 2 hour work of A plus B plus C. 2 hour work of A plus B plus C is 2 into 1 hour work, which is 2W by 6, which is W by 3. Right? W by 3 is A, B, C is 2 hour work, right? What is the remaining work? Here in the question it is given that A, B, C pipes, they work for first 2 hours, right? Therefore remaining work is, so total work W minus first 2 hours work, W by 3, right? So which is equal to 2W by 3 is the remaining work. So this remaining work has been done by A and B pipes, right? Therefore remaining work is equal to A plus B. A plus B is 1 hour work, right? A plus B means their 1 hour work into time taken by A plus B. Since remaining work is 2W by 3, A plus B is 1 hour work. So we'll leave as it is, right? B is 1 hour work into time taken by A plus B is 7, right? Therefore, so we'll get A plus B is 1 hour work. Pipe A and B is 1 hour work together. It is equal to, so 2W by 3 divided by 7 means 2W by 3 into 7, which is 2W by 21 is A plus B is 1 hour work. The 1 hour work can be expressed as total work divided by time. 21 by 2 is, so time taken by A plus B, right? So here, or you can leave as it is. Since we are going to find C's 1 hour work, C 1 hour work of C is equal to, therefore 1 hour work of C. Why do we need 1 hour work of C? To find total time taken by C, right? So 1 hour work of C is 1 hour work of A plus B plus C, right? So W by 6 is 1 hour work of A plus B plus C minus 1 hour work of A plus B, which is 2W by 21. Simplified. Since 42 is the LCM, so 6 into 7 is 42. So therefore, numerator becomes 7W minus 21 into 2. Therefore, numerator becomes 2W into 2, which is 4W. Therefore, 3W by 42, or in terms of total work, it is W by 42 by 3, or W by 14. 1 hour work of C is nothing but W, which is total work, by total time. Total time taken by C is 14. The unit of time is in terms of hours, 14 hours, right? Therefore, C takes 14 hours of time to fill the cistern, right? Or to fill the tank. Therefore, option B is the right answer. With this, I am completing this paper, students. If you want to practice all the questions from this paper, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the very best for your future exams.